Hey everybody, welcome back to my channel. This is WireDogSec, back with another video for you guys. Today's video, we are in TryHackMe. This is the SOC Level 1 updated version, so the 2025-2026 version. This is the Network Traffic Analysis module. This is the Network Traffic Basics room. Learn what network analysis is, why it is essential, how to collect network traffic, and which tools are available. Task number 1, Introduction. Network Traffic Analysis, or NTA for short, is a process that encompasses capturing, inspecting, and analyzing data as it flows in a network. Its goal is to have complete visibility and understand what is communicated inside and outside the network. It is important to stress that NTA is not a synonym for the tool Wireshark. It is more than that. It is a combination of correlating several logs, deep packet inspection, and network flow statistics with specific outlined goals, which we will discuss later on. Knowing how to analyze network traffic is an essential skill, not only for an aspiring SOC Level 1 analyst, but also for many other blue and red team roles. As a Level 1 analyst, you need to be able to navigate through the sea of network information and understand what is normal and what deviates from the baseline. In this room, we will discuss or focus on defining network traffic analysis, why you need it, what and how you can observe network traffic, and some of the sources and flows of network traffic you need to be aware of. So learning objectives: know what network traffic analysis is, know what can be observed, know how to observe network traffic, know typical network traffic sources and flows. Prerequisites: so pre-security and networking essentials. So go ahead and check my channel out for those two related information there if you want to learn more about this before you proceed with this room. I'm pretty sure maybe have a video over those. Continue to discover the purpose of network traffic analysis. Yes. So we're going to continue to task number 2. But before we get to it, if you want to help support the channel, be sure to like, comment, share, subscribe, and hit that notification bell so you know every time I upload to the channel. Without further delay, let's go ahead and dive into it. Task 2. What is the purpose of network traffic analysis? Why should we analyze network traffic? Before we answer this question, let's look at the following scenario: DNS tunneling and beaconing. You are a SOC analyst and you receive an alert stating that an unusual number of DNS queries are coming from a host named Win016 with the IP address of 192.168.1.16. The DNS logs on the firewall show multiple DNS queries going to the same TLD, which is top level domain, each time using a different subdomain. So if you take a look at this little snippet here, you got the date, you got the source, you got the query, and you got the queue type. Based on DNS logs, we can retrieve the following information: so query and query type, subdomain and top level domain, which is the TLD. We can check tools like AbuseDB, which I love. It's a great website, or VirusTotal, which is well known, to check if the domain is malicious. Host IP: we can identify the system sending the DNS queries. Destination IP: we can use tools like AbuseIPDB or VirusTotal to verify if the IP is flagged as malicious. And that's what they meant up here: AbuseIPDB, not AbuseDB. Timestamp: we can build a timeline mapping out the different suspicious queries. The DNS logs don't contain more information than that, so it is hard to draw a conclusion based on that information alone. We will need to inspect DNS traffic more thoroughly and check the content of the DNS queries and replies. This will allow us to determine the nature of these queries and replies. This scenario is a prime example of why we need network traffic analysis. Firewalls and other devices register DNS queries and the responses, but not their content. Threat actors could, for example, use TXT or text records to send command and control instructions to a compromised system. We can discover this by inspecting the content of the DNS queries. The packet capture fragment below shows the content of a DNS reply that contains C2 commands. And yes, this is a common method that threat actors will use. So go and do some Googling or ask AI about more information regarding how threat actors can use DNS tunneling and DNS queries in regards to malicious activities. So let's take a look at this little snippet again. So you have the domain name system response here, transaction, you get the flags, questions, answer, authority, additional queries, and you can see cmd1.evilc2.com, type text, answers, and you have CMD1, evilc2.com again, text, and you can see the TTL, which is time to live, length, and you can see the TXT contents. It looks like here, it looks like it's possibly like base 64 encoded, but let's see what they say down here. Why should we analyze network traffic? Generally, we will use network traffic analysis to monitor network performance, check for abnormalities in the network, examples, sudden performance peaks, slow network, etc. Inspect the content of suspicious communication internally and externally, example, exfiltration via DNS, download of a malicious zip file over HTTP, lateral movement, etc. From a SOC perspective, network traffic analysis helps detecting suspicious or malicious activity, reconstructing attacks during incident response, verifying and validating alerts. Below are two more scenarios that illustrate the importance of network traffic analysis. So let's take a look here. Based on the logs for an end user system, the system began to deviate from its normal behavior around 4 p.m. UTC. Analyzing the traffic or network traffic going to and from the system, we found a suspicious HTTP request and were able to extract suspicious zip file. We received an alert that an end user system is sending many DNS requests in comparison to baseline of the network. After inspecting the DNS request, we discovered that data was being exfiltrated using a technique called DNS tunneling. So go ahead and do some more research over DNS tunneling. Now that we know why we need network traffic analysis, let's continue with the next task to discover what exactly we can monitor. All right, so let's take a look at these questions here. What is the name of the technique used to smuggle C2 commands via DNS? Well, that's going to be DNS tunneling. All right, so do some more digging on that because you may come across it in your career. All right, so task number 3. What network traffic can we observe? The best way to showcase the traffic we can observe is in the network is by using the architecture implemented in nearly every device with a network interface, the TCP/IP stack. The image below shows the different layers of the TCP/IP model. Each layer describes the required information, the headers, to pass the data to the next layer. The information included in each header, together with application data, is precisely what we want to observe. Logs often include bits and pieces of these headers, but never the full packet details. This is why we need to do network traffic analysis. Take a look at this little infographic here. It says network traffic analysis lets you inspect and find threats in every byte and every layer of TCP/IP. So you have them all listed here: application, transport, internet link, and you can see the other information in those particular layers there. So take some time to review that, and then we're going to continue on. All right. Application. On the application layer, we can find two important information structures: the application header information and the application data itself, the payload. The information will change depending on which application layer protocol is used. Let's look at an example of HTTP. The code snippets below show the application headers of a client sending a GET request in the service response. Most web proxies and firewalls log this header data. What they don't log is the application data or payload. From the GET request, you can determine that the client is requesting a file named suspicious_package.zip. The service response includes a 200 code, which means the request was accepted. However, what you can't see in the logs is the content of the zip file highlighted in yellow. So here's the request here. You can see the GET request going to download suspicious package.zip. Host is www.tryhackrne.thn. There's the user agent curl, and you can see the rest there. So let's take a look at this response here. 200 code. It's a date and time. There's a server in Nginx, application zip, the content length, content disposition, and there's a file name right there. There's the last modified date and the rest of the information. And then down here in the yellow, you have the binary zip file bytes follow, and you have the information there about the bytes. So 10,485,760 bytes. Transport. The application data and header are segmented and encapsulated at the transport layer into smaller pieces. Each piece includes a transport header, in most cases TCP or UDP. Let's have a look at the firewall log entries below. So here is an example of that. So we have the date and time, accept TCP, source equals 192.168.1.45, destination 172.217.22.14, source port 51,432, destination port 443, flags send, length 60, and the next one is similar to that. So you have date, time, accept, TCP, you have the source, destination, source port, destination port, and the flags. Firewall logs often include the source and destination ports and flags, but all the other fields are often not included. However, they are valuable for detecting certain types of attacks, such as session hijacking. Session hijacking can be detected by analyzing the sequence numbers included in the header. If the sequence numbers are suddenly far apart, further investigation is warranted. The output below shows a series of packets called or captured with Wireshark. So here we go here, a little snippet here about that. So we have the number, the packet number, time, source, destination, protocol length, and you have the information here. All right, so here's send, ACK, push ACK, and push ACK, and you see the sequence number right there highlighted in yellow. That looks like of interest. Since the first 3 lines show a normal TCP 3-way handshake, the lines 4 and 5 show legitimate data transfer. Line 6 shows a packet from another source trying to inject itself into the session. Note the massive jump in the sequence number. Okay. Internet. When the transport layer sends down a segment, the internet layer also adds its header. If the segment is larger than the maximum transmission unit, or MTU for short, it will be divided into fragments and a header will be added to each of them. The fields that are most often logged are the source and destination IP and the TTL. This is sufficient for most use cases, but if we want to, for example, detect fragmentation attacks, we will need to inspect the fragment, offset, and the total length fields as well. There are different variations of a fragmentation attack. For example, an attacker can create tiny fragments to evade IDS or mess up the reassembly of fragments by using overlapping byte ranges. The example below shows overlapping byte ranges. The offset in line 3, highlighted in yellow, overlaps with the one line 2. This means that the complete packet can be reassembled one way or another. Attackers can use this technique to bypass IDS, for example. So here's another example of that. Time to review this. Here, fragment IP, protocol UDP, fragment IP, and then destination destination unreachable, fragment reassembly time exceeded. All right, so let's see your link. Once the internet layer finishes encapsulation, the IP packet is sent to the link layer. The link layer adds header as well, containing more information, addressing information. Most logs will display the source and destination MAC addresses. For certain types of attacks, for example, ARP poisoning or spoofing, the information in the logs won't be sufficient. For these types of attacks, we need the full packet and context. What you, for example, can't see in a log is when the MAC address appears for multiple interfaces, or when many gratuitous ARP packets are sent out with conflicting MAC addresses. The example below shows a packet capturing, detailing an ARP poisoning attack. The host with the IP 192.168.1.200 is replying to each ARP request in the MAC, or with the same MAC. So once again, take time to review this real quick. ARP, who has 192.168.1.10, tell 192.168.1. You can see the following ones up here, and then you can see where they're highlighting or noting the attacker spoof. So 192.168.1.10 is at this MAC here, and there's another one, 192.168.1.1 is at this MAC here, and then it says relayed via attacker right there. Okay. Some more questions here. Look at the HTTP example in the task and answer the following question. What is the size of the zip attachment included in the HTTP response? Note down the answer in bytes. Okay, and then we have which attack do attackers use to try to evade an IDS, and what field in the TCP header can we use to detect session hijacking? All right, so go ahead and pause the video and try to answer those questions yourself. Come back to the video, and then we will proceed forward. Hey everybody, this is WireDogSec. Just a quick reminder to subscribe to the channel and hit the notification bell. Once you hit the notification bell, be sure to set to all notifications so you know every time I post to the channel, upload a video, all that good stuff. Let's continue to grow our glorious community here. We are in the cyber trenches. We're not just reporting on it. Be sure to check out my channel as well. I have tons of videos. You can see here over 300 videos ready for you to check out and learn something from. Be sure to review my posts. I'm frequently posting new things to my channel here, including jobs and everything related to that. Also, I have tons of playlists here that you can review, make it more convenient for you. Anyway, happy defending, happy hacking. Enjoy the video. Task for network traffic sources and flows. In the previous task, we discussed what we can observe theoretically based on the TCP/IP stack. Practically, it is more helpful to focus on specific sources and flows. A corporate network typically has some predetermined network flows and sources. We can group these sources into two categories: intermediary and endpoint. The flows we can also group into two categories: north-south traffic that exits and enters the LAN and passes the firewall; east and west traffic that stays within the LAN, including LAN that extends to the cloud. Let's explore each of them below. So sources. As mentioned, two network traffic sources exist: endpoint and intermediary devices. These devices can be found within the LAN and the WAN. Intermediary sources. These are devices through which traffic mostly passes. While they generate some traffic, it is significantly lower than what endpoint devices generate. Under this category, we can find firewalls, switches, web proxies, IDS, IPS, routers, access points, wireless LANs, controllers, and many more. Maybe less relevant for us, but all the infrastructure of the internet service providers is also considered part of this category. The traffic that originates from these devices comes from services like routing protocols, EIGRP, OSPF, BGP, management protocols, SNMP, ping, logging protocols, syslog, and other supporting protocols, ARP, STP, and DHCP. Endpoint sources. These are devices where traffic originates and ends. Endpoint devices take the bulk of the network bandwidth. Devices that fall under this category are servers, hosts, IoT devices, printers, virtual machines, cloud resources, mobile phones, tablets, and many more. Flows. A network traffic flow is typically determined by the services available in the network, such as Active Directory, SMB, HTTPS, and so on. In a typical corporate network, we can group these flows into north-south and east-west traffic. North-south traffic. NS traffic is often monitored closely as it flows from LAN to the WAN and vice versa. The most well-known services in this category are client-server protocols like HTTPS, DNS, SSH, VPN, SMTP, RDP, and many more. Each of these protocols has two streams: ingress, which is inbound, and egress, which is outbound. All of this traffic passes the firewall in one way or another. Configuring firewall rules and logging properly are key to visibility. East-west traffic, or EW traffic, stays within the corporate LAN, so it is often monitored less. However, it is important to keep track of these flows when the network is compromised. An attacker will often exploit different services internally to move laterally within the network. As we see below, there are many services within this category. Click on each category to see which services it contains. All right, so we have quite a few here. We have directory, authentication, and identity services. So we have Kerberos, LDAP, authentication, queries to Active Directory, Radius, TACACS Plus, network access control, certificate authority, issuing, and internal certifications. Okay, I guess they mean internal certificates. File shares and print services, SMB, CIFS, accessing network drives, IPP, PD, printer or printing over the network. All right, next one, router switching and infrastructure services, DHCP, traffic between hosts and the DHCP server, ARP broadcast messages, internal DNS, routing protocol messages, application and communication, database connections, SQL over TCP, microservices, APIs, REST, and gRPC calls between services. Backup and replication, file replication between data centers or to backup servers. Database replication, MySQL, binlog replication, PostgreSQL, streaming, and more. Monitoring management, SNMP, device health metrics, syslog, centralized logging, NetFlow/IPFIX or IPFix, traffic flow telemetry, other endpoint logs sent to a central logging server. Neat. Okay. Flow examples. Let's have a visual look at some of the network flows mentioned above. So first one up is HTTPS. There are different variations of HTTPS network traffic flows. Let's examine a flow where the web proxy does TLS inspection. Host requests a website. This request is sent to the next-gen firewall or NGFW W, which includes a web proxy. The web proxy will act as the web server and simultaneously establish a new TCP session with the actual web server and forward the client's request. When the web proxy receives the answer from the web server, it inspects its contents and then forwards it to the host if deemed safe. To summarize, we have two sessions, one between the client and the proxy and the other between the proxy and the web server. From the client's point of view, it has established a session with the web server. So here is a infographic of that here. So with the web server over here, TLS session between web server and web proxy. So the WAN and LAN, right? Okay. So next gen firewall, the web proxy. On the other side here, we have the router, switch, and host, TLS session between host and web proxy. See, the next gen firewall sits as that middleman to inspect that traffic there. And let's continue on to external DNS. DNS traffic within a corporate network starts when a host sends a DNS query. The host sends the query to the internal DNS server on port 53, which will then act on behalf of the host. First, it will check if it has an answer to the query in its cache. If not, it will send the query via the router through the firewall to the configured DNS server. The answer will then follow the same path to the internal DNS server, which will then forward it to the host. The network diagram below shows a simplified flow. So if egress plus ingress DNS traffic here, okay. And the WAN LAN, next gen firewall, you have the router, level 3 switch here, and over here we have the DNS server and the host. So this is how the flow would go, right, in a simplified version. So just take a look at that, familiarize yourself with that real quick. And let's continue on. SMB with Kerberos. When a host opens a share to, for example, file share marketing on SMB session is set up. First, authentication is done via Kerberos. When a user logged in on the host, it authenticated with the key distribution center, or KDC, on the domain controller and received a ticket granting ticket, or TGT, to request service authentication tickets. Now the host requests a service ticket using the ticket granting ticket it received earlier. The host then uses this ticket to establish the SMB connection. Once the SMB session is set up, the host can access the share. Below, we see a simplified network diagram of the flow. So once again, take a quick look here. All right. So over here, number one, request SMB service ticket. Number two, establish SMB session. So there's the SMB server. There's the switch again. There's the KDC server, on the domain controller. All right, and then the rest here we have the router and the firewall. Okay. Some more questions. All right, let's see here. Which category of devices generates the most traffic in a network? Before an SMB session can be established, which service needs to be contacted first for authentication? What does TLS stand for? All right, so I think we can just answer some of these quite off the bat here. And let's see here. I think this was endpoint. Next one, which service needs to be contacted first for authentication? And that was going to be Kerberos up here. So let's go ahead and grab that real quick, plug it in as our answer. TLS, of course, transport, layer security. All right. Next task is task number 5. How can we observe network traffic? We also have some practical application, it looks like here. So I'm just going to scroll through this real quick. Okay, it's quite lengthy. So let's take a look here. Now that we have covered what we can and should observe in a network, let's examine how. As mentioned in the introduction, network traffic analysis focuses on combining multiple sources of information, analyzing them, finding patterns, and using the results to inform actions. We can obtain these sources of information in multiple ways: logs, full packet capture, network statistics. Logs are our first entry into acquiring information about what is going on in the network. Each system and protocol in a network includes a way of logging information. It is essential to know that there is no universal standard for implementing logging on each system and protocol. Each vendor chooses how to implement logging for themselves. For example, Microsoft implements Windows event logs. Also, the data that is logged is up to the vendor. Most vendors will not log a full packet as it enters or exits the system. They will log some fields that they deem useful, such as source IP address and destination IP address. On the terminal below, we can see some example logs of authentication on a Linux host using the syslog format, and an Apache web server access log that uses the CLF standard. So auth log here, we have the date timestamp here, SSHD, web01 appears to be the host. I set the password for ginseng from this IP on this port. Okay, Apache web server access log, IP address, you have the timestamp again. There's a request, it's a GET request. You're going to index.html 200 error code. So you can see the rest there. Even though there is no standard logging way, there are some protocols that offer a standardized way of sending log messages from devices to collectors. For example, syslog and SNMP. When the logs don't provide enough information, we must dig deeper. To do so, we need to correlate logs, inspect full packet captures, and check network statistics. Now, you may not always have these packet captures. Okay, you may have to do some at real time and capture those. Sometimes organizations will have limits on these, like let's say they just go back like 7 days, 14 days or whatever, because it's expensive to hold this information on your systems. It takes a lot of storage space, and also maybe regulations and stuff like that. So it depends on your organization. Anyway, full packet capture. In task 3, we discussed what a full packet looks like. Now we want to know how to capture and inspect those packets. To do this, we have two options: install a physical network tap and configure port mirroring. So first one up is going to be network tap. A network tap is a physical device you place in line in your network. These devices create a copy of all network traffic that passes without affecting performance. That copy data is then forwarded to a packet capture box, IDS, or other system using the dedicated monitoring port. It is interesting to know that a tap operates only on the link layer of the TCP model. It does not need a MAC or IP address because it copies the electrical/light signals and sends them to its monitoring port. This way, there is no added delay to the network. The image below shows an example of a network tap. So there's one that I guess would look like. Port mirroring is a software approach to copying packets from one port on an intermediary device to another that is attached to, for example, an IDS packet capture box or other systems. Each vendor has its own name. Cisco, for example, calls it span, right? Span ports. On the terminal below, we can see how to configure span on a Cisco device. In this example, the packets going from fast Ethernet 01 and duplicated are being sent to fast Ethernet 02. So we can see how it would look in Cisco, right? If you ever looked at a Cisco CLI or command line interface, it looks something like this, okay? So monitoring session 1, source interface, fast Ethernet 01. Next one, monitor session 1, destination interface, fast Ethernet 02. The image below shows what this would look like. The WIN001 sends packets through the switch to communicate with the server. When the packet arrives at the switch, it gets duplicated and it is also sent to the monitoring device. So we have the switch here. So here's the host, right? Sent to the switch. Number 2 is the server. Number 3, copy packets, goes to the monitoring device. All right, here's the bigger, well, somewhat bigger picture, I guess. Okay, so now that we have that down, let's continue on. Note that the intermediary devices do not necessarily need to be physical. Port mirroring can also be configured on a virtual device such as a VMware vSwitch. Cloud environments also have specific services that offer mirroring. AWS, for example, offers VPC traffic monitoring. Best practices. When doing full packet capture, we need to take some things into account. Placement. Depending on which traffic we want to capture, we need to place the tap or configure the mirror in the right place. Duration. Full packet capture require a proportionate amount of storage, as I mentioned earlier. If you capture traffic on a 1 gigabit per second line for a whole day, we would need an average of 10.8 terabytes of storage space. Imagine the amount of storage we would need on 10 gigabits or 40 gigabit lines. Mirror versus tap. Physical taps offer close to zero performance reduction. Mirroring can impact performance when a huge amount of traffic passes through the mirrored port. Okay, and exercise. Open the static site and complete the 2 exercises by placing the tap in the correct position and uncover the flag in the traffic. Fill in the flags at the end of this task. You can open the static site by clicking the View Site button and the top of this task. The static site will open in split screen. To open the static site in full screen, click the full screen button at the static site. Okay, so let's see here. Tools. Now that we know how to do full packet captures, let's have a look at the tools available to analyze these packets. So we have Wireshark, which is well known, TCP dump, which is a command line tool, IPS, IDS, like Snort, Suricata, and Zeek. These are some of the many tools that are available to analyze full packet captures. In the following rooms, in this module, we will focus on using Wireshark. Network statistics. There's also T-Shark, which is like basically the command line version of Wireshark. Network statistics. Another great way to find anomalies in your network is to gather metadata about the data flowing through the network, such as counting the number of DNS requests that a host sends out. A few protocols to facilitate this. We will briefly discuss them, or 2 of them, NetFlow and IPFix. NetFlow is a protocol developed by Cisco that collects metadata about traffic flowing in a network. It is a great way to collect or to detect things like C2 traffic, data exfiltration, and lateral movement. The image below shows a simple NetFlow output. As we can see, the sample does not contain individual packets, but metadata about the flow of packets going from the source IP 12.1.1.1 to destination IP 13.1.1.2. So here's that little snippet they're talking about here. There's the source address, there's the destination address. You can see some other metadata information there. Me, obviously, I prefer full packet captures, but like it said before, there's limitations on those often. Okay, so the Internet Protocol Flow Information Exports Protocol, that's a mouthful, IPFix, can be considered as the successor to NetFlow. NetFlow was initially a proprietary protocol from Cisco. This means that the protocol was designed for Cisco systems only from NetFlow version 9 on did Cisco include templating, so other vendors could adapt it to their devices. In collaboration with Cisco and other vendors, the IETF created IPFix and released it as a vendor neutral standard. It offers features similar to NetFlow, but includes more flexibility in configuring which fields to capture. To implement NetFlow or IPFix, we don't need a whole new set of infrastructure or dedicated servers. Most vendors implement these protocols standards in their devices. We just have to enable and configure the protocol and have a place to send the metadata. You don't need a dedicated server for collecting this data. Many next-gen firewalls, IPSs, and IDSs have an implementation to collect and analyze flow data. Sweet. Okay, so we have some questions here. What is the flag found in HTTP traffic in scenario 1? Okay, what is the flag found in DNS traffic scenario 2? So once again, we're going to take a look at that view site button up here. All right, so go ahead and try that yourself and then come back to the video and then we will proceed forward. All right, let's go ahead and take a look at this exercise here. Instructions, objective. This exercise focuses on placing a network tap in the most efficient location, inspecting the network traffic. Only the most efficient location will allow you to view network traffic. Other locations won't. In real life scenarios, every location would show network traffic. Okay, step-by-step instructions. Start scenario. Click the start button to start the scenario. There are 2 scenarios in this exercise. Network tap, drag and drop the network tap. Place it on the right place to capture network traffic. Devices, click on the devices button to see the IP and MAC addresses for each device. 4, packet tracer, monitor the captured traffic in the packet tracer panel. Once the network tap is placed, need to start over. Click the reset button to restore the initial state of the exercise. Okay, so let's take a look here. All right, so we got to click start here and let's see if we can zoom in a little bit here and make it a little bit easier. So we have quite a few things here. WP1, internet, looks like firewall, routers, I guess those are switches, and then we have looks like a mail server, DNS server, and we have endpoints here, Windows boxes. Okay, so let's take a look here and see what we could do. So here's the tap up here at the top here, and we just got to drag and drop. All right, let's see here. So there's firewall. All right, so this WP device here and firewall router. Let's try that. here. Let's drop a tap there and see what it does. Okay, awesome. Correct, you place the tap at the web proxy. All devices in the network send their HTTPS request to the device. The web proxy then initiates the connection to the destination. Placing the tap on this device means capturing all web traffic exiting and entering the network. Note, inspect the packets in the packet panel to find the flag, and then click on the proceed button to continue to scenario number 2. Okay, so we need to take a look at some packets, I guess. You scroll over there. Okay, sweet. Let's see if we can locate this real quick. I guess we can click in here. Okay, sweet. So downloads update.zip file there. It looks odd. 200K. Application zip. Okay, we found out about that earlier. Here's the get request. All right, and let's see here. Does it have the error codes or the 200 codes there? Okay, there's 200 codes. 200 codes, 200 codes. Let's check out this one here. What's this do? Okay. And there's other pages. Wow. Okay, there's quite a few things here. So let's just take a look at this info. Intranet. All right. Looks like it's going. There's downloads again right there. Let's take a look at 3 here. And there's another get. Okay, install .ps1. That looks really suspicious there. And let's see here. Path downloads install.ps1. So PowerShell file there. There's another 200 here. Application zip. Ac destination. Okay. Let's see. Okay, there it is. So I guess you have to sift through all these packets until you find that flag. I mean, but I just skipped around as you saw there and scrolled through there. But anyway, we've got the flag, so I'm gonna plug that one in as our answer there. But I assume you have to go through each and every one of those packets there, which can take some time. Next one, we need to find this DNS traffic one and see what we can do here. So proceed, and let's see. DNS infiltration. A workstation was compromised. Some malicious C2 instructions were infiltrated via DNS records, text records. If we had wanted to capture this DNS traffic, where will we have to place the tap at the most efficient place to view DNS traffic, find the DNS text record, and get the flag. Okay, so basically what we just did before. So go ahead and click start here. Is this it? Let's zoom out a little bit. No, there's more. Okay. All right, zoom back in. And it's the same thing here, right? So, well, there's the DNS server there, right? So let me think for a second here. All right, so let's go ahead and drop this down here. All right, correct. You place the tap on the DNS server. This device handles all external DNS queries and replies on behalf of the host, which means all external DNS traffic passes through. Okay, sweet. Right, so for that DNS section, just to go back to what we referenced inside of task number 2 here, it talks about DNS tunneling and beaconing. All right, so you're looking for those DNS queries, right, as we saw there in those packet captures, and also in this here, which is the, I believe it said this was the Wireshark packet capture or whatever. But anyway, so down here on the answers or the responses, you can see the information in the TXT section here, as we saw there, and we were able to grab our flag. So this is what we saw in that second section, or that second part of that practical hands-on keyboard exercise there, okay? And this also explains it again if you want to go back and reference it. So I guess we're doing the same thing here. We've got to try to click around and try to figure out where that flag is. Okay, so let's see here. Let's see. I just want to click on this first one here. All right, let's take a look at this info section. Response, news.portal, Windows, time Windows. Okay, so we're trying to look for something that looks kind of out of the ordinary here. So we'll have to flip through some of these pages. It looks like mail, pull NTP. Okay, this was flagged before, so let's take a look at this. Right, okay. So that was like a suspicious domain, and even has C2 in there. So let's take a look at this next one here. There we go, right there. Got it. So we managed to find that, right? Looking at those requests and replies in DNS, as we read about earlier. Okay, so we were able to find that flag there. But ideally, in the real world, you're going to be sifting through some packets, and with Wireshark and T-Shark, it makes things a lot easier. So you can build out your custom, filters in Wireshark or T-Shark there to help you sift through packets and whatnot. But this is an interesting exercise, just to give you the underlying concept of what you may encounter in the real world. Why is this taking forever? Okay. We're done with that. Now that we know what NTA is, why we need it, how to capture network traffic, analyze it, we are ready to get hands-on with effectively analyzing network traffic using a tool called Wireshark. Proceed to the next room to get started with the basics of Wireshark. I'm ready to do some traffic analysis. All right, sweet. We are done with this room here. If you enjoyed the content, enjoying the channel, you want to help support the channel, be sure to like, comment, share, subscribe, and hit that notification bell so you know every time I upload to the channel. Also, there is another website out here if you want to expand your knowledge and skill set on Wireshark. I believe I already have mentioned it in the other Wireshark video, so go ahead and check that out. But anyway, thank you for watching. Happy hacking, happy defending. Stay safe in the cyber trenches. See you later. Hey everybody, this is WireDogSec. Just a quick reminder to subscribe to the channel and hit the notification bell. Once you hit the notification bell, be sure to set to all notifications so you know every time I post to the channel, upload a video, all that good stuff. Let's continue to grow our glorious community here. We are in the cyber trenches. We're not just reporting on it. Be sure to check out my channel as well. I have tons of videos that you can see here, over 300 videos ready for you to check out and learn something from. Be sure to review my posts. I'm frequently posting new things to my channel here, including jobs and everything related to that. Also, I have tons of playlists here that you can review, make it more convenient for you. Anyway, happy defending, happy hacking, enjoy the video. Hey everybody, welcome back to my channel. This is WireDogSec, back with another video for you guys. Today's video, we're going to be covering the Wireshark, the basics room on TryHackMe. This is a free room, and we're going to learn about how to navigate our way through Wireshark, looking at various different things in here. And as usual, before we get into it, please hit that subscribe button if you're new here. Hit the like button if you like the video, and then comment below on your thoughts and opinions on the video information discussed. All right, without further ado, let's go ahead and get into it, folks. As usual, when there's a lot of text to read through or a lot of screenshots to go through, be sure to pause the video and then read through it yourself or take a look at the screenshot yourself, or even better, go to the room and then go along with me in the video. All right. I'm going to try to read everything, but I may skim through a few sections, yada, yada, yada. Let's go ahead and get into it. Task number 1, introduction. Wireshark is an open source cross-platform network packet analyzer tool capable of sniffing and investigating live traffic and inspecting packet captures, aka PCAPs. It is commonly used as one of the best packet analysis tools. In this room, we will look at the basics of Wireshark and use it to perform fundamental packet analysis. Note, a VM is attached to this room. You don't need to use SSH or RDP. The room provides a split view feature. We suggest completing the network fundamentals module before starting working in this room. Be sure to check out this module here if you haven't done so already, and then come back to the video and come back to the room and work through it. There are two capture files given in the VM. You can use the http://1.pcapng file to simulate the action shown in the screenshots. Please note that you need to use the exercise pcapng file to answer the questions, right? So the simulate one is going to be the HTTP one up here. So I'm just going to copy and paste it. All right, Control C and then Control V for you who don't know how to do that. And then same thing here. And we're going to continue on to task number 2. Let's go ahead and do that. May as well start the machine up, and because it might take a few minutes to start. So let's continue on to task 2. Okay. Task number 2. Tool overview. Use cases. Wireshark is one of the most potent traffic analyzer tools available in the wild. There are multiple purposes of its use: detecting troubleshooting network problems such as network load, failure points, and congestion detection, security anomalies such as rogue hosts, abnormal port usage, and suspicious traffic, investigating and learning protocol details such as response codes and payload data. Note: Wireshark is not an IDS. It only allows analysts to discover and investigate the packets in depth. It also doesn't modify packets, it reads them. Hence, detecting any anomaly or network problem highly relies on analyst knowledge and investigation skills. Right, that goes back to fundamental knowledge, learning the fundamentals of networking so you know what you're going to be looking at inside of tools such as Wireshark. GUI and data. Wireshark GUI opens up with a single all-in-one page, which helps users investigate the traffic in multiple ways. At first glance, 5 sections stand out. You got the toolbar. The main toolbar contains multiple menus, shortcuts for packet sniffing and processing, etc., etc. Display filter bar, the main query and filtering section. Recent files, list of the recently investigated files. You can recall listed files with a double click. Capture filter and interfaces. Capture filters and available sniffing ports. Network interfaces. The network interface is the connection point between a computer and a network. The software connection, e.g. LO, ETH0, and ENS33 enables networking hardware. Status bar, tool status, profile, and numeric packet information. Below picture shows Wireshark's main window. The sections explained in the table are highlighted. Now open the Wireshark and go through the walkthrough. Awesome. So as soon as this machine finishes firing up, but let's take a look at this picture here. And it's got everything listed out here. You got the toolbar at the top, and of course you got the display filter. You can go in and put on all your like Wireshark queries and stuff to filter out all kinds of stuff. Say you want to look at HTTP packets only, so you type something in dealing with HTTP solely. Then recent files, of course. Recent files, self-explanatory. Capture filter, available sniffing interfaces. Which interface are you going to use to sniff traffic on? Then of course the status bar. All right, looks like it's fired up already. So let's go ahead and open it. And it says loading PCAP files. The above picture shows Wireshark's empty interface. The only available information is the recently posted or processed http1.cap file. Let's load that file and see Wireshark's detailed packet presentation. Note that you can also use the file menu, dragging and dropping the file or double clicking on the file to load a PCAP. Awesome. So it's up here, file name. It's going to be displayed at the top, packet list. Everything's going to be here in the middle, all the juicy stuff. And then packet bytes, and then packet details, some other information there. The file name, total number of packets, displayed packets, etc., etc. And it's going kind of slow here. Let me make sure it's opening. There we go. Now we can see the process file name, detailed numbers of packets, packet details. Packet details are shown in 3 different panes, which allow us to discover them in different formats: packet line pane, packet details pane, and packet bytes pane. So let's see here. It's finally firing up, and it's going to continue on until it finishes. Awesome. Okay. So it wants us to load up a file here, and let's see this HTTP one, and it's already in this one in recent files here. So going through, and it looks like a similar screen as we saw in the screenshot above. You got the toolbar stuff up here. You got the display filter. You can go in and type in different packets or queries you want to see, and then it's got the other information down here for the packets and such, packet details and all that. So let's go ahead and scroll back down here. And coloring packets, along with quick packet information, Wireshark also color packets in order of different conditions and the protocol to spot anomalous protocols and captures quickly. This explains why almost everything we see is green in the screenshots. This glance at packet information can help track down exactly what you're looking for. During analysis, you can create custom color rules to spot events of interest using display filters. It will cover them in the next room. Now let's focus on the defaults, learning how to view and use the represented data details. Wireshark has two types of packet coloring methods: temporary rules that are only available during a program session, and permanent rules that are saved under the preference file profile and available for the next program session. You can use the right-click menu, view coloring rules menu to create permanent color rules, colorize packets list, etc., etc. Temporary packet coloring. Right click and then a conversation filter, which is covered in task 5. The default permanent coloring is shown as below. So you just go to view, and then you can go down to this coloring rules section here. There we go, and take a look at the stuff here. You know, same thing as a screenshot. And this is traffic sniffing. You can use the shark button to start sniffing traffic, and that's going to be this button here, right here, to start sniffing traffic or capturing traffic. The red button will stop it. So I'm going to click this, right? Permission denied. Okay. Anyway, the red button will stop it and merge PCAP files. Wireshark can combine two PCAP files into one single file. You can use file merge. So if you want to do that, just go to file and then the merge here, which is grayed out currently. So let's go back and open this up. File and the merge. And there you go. So I'm going to close out of this. Hit cancel. And let's continue on. Merge pass menu to merge the PCAP process one file or process one. When you choose the second file, Wireshark will show the total number of packets in the selected file. Once you click open, it will merge the existing PCAP file and chosen one and create a new PCAP file. Notice that you need to save the merged PCAP before working on it. It says see image, and it shows you the step-by-step process of doing that. So be sure to go through this and take a look at that. View file details. Knowing the file details is helpful, especially when working with multiple PCAP files. Sometimes you will need to know and recall the file details, the file hash, capture time, etc., to identify the file, classify, and prioritize it. You can view the details by going to statistics, capture, file properties, or by clicking PCAP icon in the bottom left, or in the left bottom of the window. So let's go ahead and try that. Statistics, and then capture file properties at the top here. And there you go. It's got all kinds of information in here. So be sure to take your time and then review some of this information in here. Familiarize yourself with the Wireshark GUI interface, all the options you can use. And it goes through the step-by-step process of doing that, which we just did here. So I'm going to go ahead and minimize that. Use the exercise.pcapng file to answer the questions below. So let's go ahead and load that in here. Go into, it should be in recent. Yep, exercise.pcap. All right, let's go ahead and load this bad boy. See what we got. Read the capture file comments. What is the flag? What is the total number of packets? What is the SHA-256 hash value of the captured file? Let's see what's going on here. Why it didn't load? There it goes. It's just probably a really big file. Okay, so capture file comments. Let's go ahead and take a look and try to find that information. Okay, in order to get to the capture file comments, remember we got to go to statistics and then capture file properties to see that information here. So I have it pulled up here, and it wants us to take a look at the comment stuff to find that flag. So I'm just gonna increase this window here, and there's the flag right there. So let's gonna go ahead and copy and paste that into there to get that answer. Oops. Okay. Go ahead and copy and paste it. Awesome. Then it wants us to get the number of packets, which is going to be here at the bottom, 58,620. So let's do that, 58,620. And it wants us to find the SHA-52 hash value of the captured file, and I believe that was in the same area as the statistics here. Where's that? Right here. This should be it. So I'm going to go ahead and copy and paste that, and then to get that last answer here. So copy and paste. Awesome. So let's go ahead and move on to task number 3. And I may need to open up a new window to get a bigger view of this if the time comes. And I'll go ahead and do that whenever the time comes. So let's go ahead to task number 3 here. Packet dissection. Packet dissection is also known as protocol dissection, which investigates packet details by decoding available protocols and fields. Wireshark supports a long list of protocols for dissection, and you can also write your dissection scripts. You can find more details on dissection here, so check out that link. Note, the section covers how Wireshark uses OSI layers to break down packets and how to use these layers for analysis. It is expected that you already have background knowledge of the OSI models and how it works. If you don't, go ahead and check out that network fundamentals room and do some research on that if you're not familiar with OSI model layers. Packet details. You can click on a packet in the packet list pane to open its details. Double click will open details in a new menu. Packets consist of 5 to 7 layers based on the OSI model. We will go over all of them in an HTTP packet from a sample capture. The picture below shows viewing packet number 27. And let's see here. see if we're going to actually get into other things before I try to close out this window here. I guess, yeah, we're going to use the same file down below. But all right, let's go ahead and take a look at these screenshots here. Okay, now I have increased the view for this, so hopefully you guys can read that screenshot a little bit better. Packet details, click on the packet list pane, double click in it, open a new window, and you can look at the packet information there, 5 to 6 layers. Sample capture the packet below, looking at packet number 27, and you can see the details as I double clicked it there. See below here. And then it says each time you click a detail, it will highlight the corresponding part in the packet's bytes pane, right? That's the one next door here. And this is, let's have a closer look at the details pane. Is HTTP stuff here. So we can see 7 distinct layers of the packet frame, packet source, MAC, source IP, yada, yada, yada. Below, we will go over the layers in more detail. See layer 1, this will show you the frame packet you're looking at specific to the physical layer of the OSI model. Look at the image here, and it's got it listed out here with all the information. So go ahead and minimize that. And then layer 2 stuff is going to deal with the MAC data link layer, OSI model. Same thing here. Layer 3, IP, network layer of the OSI model. It's got information listed out there in the screenshot. Layer 4 is going to be the transport layer of the OSI model. It's got TCP information there. Layer 5 is going to be, oh, okay. Let's go back a step. Protocol errors, continuation of the 4th layer shows specific segments of the piece of the TCP that we needed to be reassembled. So it's got the information there. And then the application protocol, layer 5, HTTP, FTP, SMB stuff. So if you want to look for that information, you'll be looking at that particular section. And then application data, this extension of 5th layer can show the application specific data. So let's go ahead and take a look at that screenshot here. And this is what it looks like. Okay, and it says now that we understand what a general packet is composed of, let's look at various application protocols and their specific details. We're going to use the exercise PCAP again to answer these questions. Wants us to view packet number 38. Which markup language is used under the HTTP protocol? This is what is the arrival date of the packet, yada, yada, yada. So let's go ahead and open up that split view and then try to answer some of these questions here. All right, packet 38, we're looking at right now, says, which markup language is used under the HTTP protocol? So I'm assuming it's going to be this extendable markup language. So let's type that in. Or extensible markup language. Extensible markup language. Awesome. What is the arrival date of the packet? It wants us to put it in the month, date, year format. And to do that, I went ahead and went to view here, and then I went to time display format, and then display date and time of the day, try to make it easier. So this is going to be, looks like it's going to be 05/13/2004. So 05/13/2004. What is the TTL? And since that's like network information, we're going to look at the Internet Protocol version 4 information here. So hit that little drop down arrow, and it should be right here. Time to live, which is going to be 47. And that's basically the number of hops it takes before it gets discarded, for the packet gets discarded. So how many hops it takes to get to the destination before it gets discarded by the last router. What is the TCP payload size? So let's see. Let's go ahead and take a look here. Go ahead and minimize that, and then let's look at the payload size. So let's go ahead and try to find that information down here. Let's see here. TCP payload 424. So 424. What is the E tag value? E tag should be under the hypertext transfer protocol information here. It says E tag. Let's see if I can just copy and paste this. Let's go ahead and say, let me copy value. Let's see if it'll copy over. Awesome. So go ahead and copy this middle information here and then paste it in. And that should be the answer for that one. Great. Cool. Now let's move on to task number 4. All right, task number 4, packet navigation. We're getting to some exciting stuff here, folks. Hopefully you're still sticking around and paying attention. Packet numbers. Wireshark calculates the number of investigated packets and assigns a unique number for each packet. This helps an analysis process for big captures and makes it easy to go back to a specific point in time And take a look at this here, and it's got the number right there and everything highlighted below, so be sure to check out that screenshot. Go to packet. Packet numbers do not only help to count the number of packets or make it easier to find and investigate packets or specific packets. This feature not only navigates between packets up and down, it also provides in-frame packet tracking and finds the next packet in particular part of the conversation. You can use the Go menu and toolbar to view specific packets. Now we're going to take a look at all this stuff as we go through the exercises and all that, but right now I'm just going to go through the screenshots and then take a quick look at what they're talking about here. All right, go to packet, and then go ahead and list out the number for that packet, and then click that button to go to that specific packet to display the information down below. Find packets apart from the packet number. Wireshark can find packets by packet content. You can use the edit find packet menu to make a search inside the packets for a particular event of interest. This helps analysts and administrators to find specific intrusion patterns or failure traces. There are two crucial points in finding packets. The first is knowing the input type. The functionality accepts 4 types of input: display, filter, hex, string, and regex. String and regex searches are the most commonly used search types. Searches are case insensitive, but you can set the case sensitivity in your search by clicking the radio button. The second point is choosing the search field. You can conduct searches in 3 panes: packet list, packet details, and packet bytes. And it is important to know the available information in each pane to find the event of interest. For example, if you try to find the information available in the packet details pane and conduct the search in the packet list pane, Wireshark won't find it even if it exists. So it's got everything here listed out, highlighted. First thing I'm going to do is find packet. It's going to open up this stuff here, right? And this is where you're going to type in the information you're going to be looking for, and it's looking for download, right? And number 3 here, and it's going to go down to that specific packet containing that information, and you can see the rest there. Mark packets. Marking packets is another helpful functionality for analysts. You can point to a specific packet for further investigation. By marking it, it helps analysts point to an event of interest or export particular packets from the capture. You can use the edit or the right-click menu to mark unmarked packets. Marked packets will be shown in black regardless of the original color representing the connection type. Note that the marked packet information is renewed every file session, so marked packets will be lost after closing the capture file. And it tells you how to get there, edit, and then go ahead and mark the packets there. It's got them listed out here in black. Mark unpack, mark packets, right click in it. Packet comments. Some of the packet marking, commenting is another helpful feature for analysts. You can add comments for particular packets that will help the further investigation, or remind and point out important specific points for other layer analysts. Unlike packet marking, the comments can stay within the packet file until the operator removes them. It's got everything shown out in the screenshot here, packet comment, right? You can do it this way, and then it can opens up this little box here. You type in your comments, etc., right? And then you click the OK button. Moving on here, export packets, capture. Files contain thousands of packets in a file. As mentioned earlier, Wireshark is not an IDS, so sometimes necessary to separate specific packets from the file and dig deeper to resolve an incident. This functionality helps analysts share the only suspicious packets decided scope. Thus, redundant information is not included in the analysis process. You can use the File menu to export packets. All right, File, export specific packets, and then go ahead and follow along. It's pretty much click through stuff here. All packets, select the packets only, yada, yada, yada. Export objects, files. Wireshark can extract files transferred through the wire. For security analysts, it is vital to discover shared files and save them for further investigation. Exporting objects are available only for selected protocol streams: DICOM, HTTP, IMF, SMB, and TFTP. And it's got it here, file, then export objects, and select which one you want to select, or which protocol you want to select, and it opens up a new box here, and select the particular file you want to export out of there. Time display format, which we already looked at earlier, view time, display to change the time. All right, so let's go down here, and it shows you how they look, right? UTC format, default time. I like using like UTC or something, because trying to go to this default time is kind of a pain in the neck sometimes. Export or expert info. Wireshark also detects specific states of protocols to help analysts easily spot possible anomalies and problems. Note that there are only suggestions, and there's always a chance of having false positives / negatives. Export or expert info can provide a group of categories and 3 different severities. Details are shown in the tables below. You got chat, blue information, user workflow, note, cyan, warm, yellow, error, problems like malformed packets. Okay, frequently encountered information groups are listed in the table below. You can refer to Wireshark's official documentation for more information on the expert information entries. You got group info, yada yada yada. Checksum, errors, comment detection, deprecated protocol, malform, packet detection. Pretty much self-explanatory. You can use the lower left bottom section in the status bar, analyze expert information menu to view all available information entries via a dialog box. It will show the packet number, summary, group protocol, and total occurrence. I don't think I've ever used this in the real world, but maybe we'll take a look at here in this little lab environment. So we're going to take a look at the exercise.pcap.ng file again and answer some of these questions. So let's go ahead and do that. Okay, search the R4W string in packet details. What is the name of artist number one? And to do that, you just go to edit, find packet, right, and type the information in here, which I've already done. Click find, and it'll go down to that specific packet, right? You're going to want to search through here. We go back here. Okay, search through here for that information. You'll see it right here. So let me see if it will actually let me click in here and grab it. I guess not. Okay, so I'm just going to type it in. So it was R4W, yeah, R4W 8173. 8173. Awesome. Okay, wants us to go to packet number 12, read the comments, and this is what's the answer. So let's go ahead and do that. We're going to go at the top here, go to packet, type in 12, hit enter. It's going to go up here, and you can see there's already some stuff in here, but I'm going to right click here and go to packet comment to look at the comment stuff in here. It's got a lot of information. Let me just expand this a little bit. Go to packet number 39765. Look at the packet details pane. Right click on the JPEG section and export packet bytes. This is an alternative way of extracting data from a capture. What is the MD5 hash of the extracted image? So I'm just going to copy this in there and go to that packet. So let's go ahead and do that. Go to, again, right, and okay, it didn't let me do that. So let's go back and find it again. Comment, it was 39765. So let's go ahead and type that in. Clear this out. 39765. Hit enter, and here we go. Okay, so it's got the JPEG stuff here, right? Okay, yeah, you're gonna right click it and then export packet bytes, like it said, and it's gonna save it to the desktop. Let's just, I don't know, 1.jpg or whatever. JPG. Okay, and then you're gonna hit OK at the bottom here. And it wants us to get the MD5 hash for that. So see it right there. And let's just open up a terminal here. All right, let's see where we're at. Okay, so let's go ahead and CD into the desktop. Okay, LS on it, and then I believe it's MD5 sum 1.jpg. And this should be the answer, so let's go ahead and try that. Copy it and then paste that in there. Awesome. Okay, there's a text file inside the captured file. Find the file and read it. What's the alien's name? So let's go ahead and do that. What I'm gonna do is you're gonna go to file, right? And then you're gonna go to export objects as HTTP and type in .txt. Get that information here, right? And let's go ahead and save that to the desktop as well. Note.txt. Okay, they're gonna hit save or OK down here at the bottom. Close this out, and then let's go ahead and open it up, see what it says. Okay, there's a lot of stuff in here. So we're gonna scroll through this and try to find the alien's name. Okay, I had to open this up in a bigger window so you can actually see what it says. It's gonna be packet master. And the last question wanted us to go to the expert viewer information here and find the number of warnings. So we're going to click that at the lower left corner there, and this is warning, right? Going to scroll over, and it should be, yeah, 1636. So let's go ahead and put these answers in there and then follow up with the next task. All right, guys, we're getting close to the end here. Task number 5 here. Make it a little bit bigger. Packet filtering. Packet filtering. Wireshark has a powerful filter engine that helps analysts to narrow down the traffic and focus on the events of interest. Wireshark has two types of filtering approaches: capture and display filters. Capture filters are used for capturing only the packets valid for the used filter. Display filters are used for viewing the packets valid for the used filter. We will discuss these filters, differences, advantages, usage in the next room. Now let's focus on basic uses of the display filters, which will help analysts in the first place. Filters are specific queries designed for protocols available in Wireshark's official protocol reference. While the filters are only the option to investigate the events of interest, there are two different ways to filter traffic and remove the noise from the capture file. The first one uses queries, the second one uses the right-click menu. Wireshark provides a powerful GUI. There is a golden rule for analysts who don't want to write queries for basic tasks. If you can click on it, you can filter and copy it. Awesome. Apply as filter. This is the most basic way of filtering. While investigating a capture, you can click on the field you want to filter, right-click menu, analyze, apply as a filter. It has it displayed out here, right? It says note the number in total display packets are shown in the status bar. Okay, it's got that there at the bottom. Packets displayed 43. So conversation filter, applies filter option. You'll filter only on a single entity of the packet. This option is a good way of investigating a particular value in packets. However, suppose you want to investigate a specific packet number and all linked packets focusing on IP addresses and port numbers. In that case, the conversation filter option helps you view only the related packets and hide the rest of the packets easily. You can click the right-click menu or analyze conversation filter, and it's got it out here. Right-click it, conversation filter, TCP. All right, it's going to have the query out there, and then at the bottom, it's got the total number of packets, etc., etc. Colorize conversation. Right, this option is similar to the conversation filter with one difference. It highlights and it highlights the linked packets without applying a display filter and decreasing the number of viewed packets. This option works with coloring rules option and changes the packet colors without considering the previously applied color rule. You can use right click or view colorized conversation menu. So note that you can use view colorized conversation, reset or colorization, right? So you can right click it, uh, colorize conversation here, TCP, and then pick the color, right? And it's got it out there in those fancy colors for you. And it shows it in 3. You can view colorized conversation, right? You want to reset it back to normal, so you're going to select the reset colorization there, and it looks normal like it was before. So continue on. Prepare as filter. Similar to apply as filter, this option helps analysts create display filters using right-click menu. However, unlike the previous one, the model doesn't apply the filters after the choice. It adds the required query to the pane and waits for the execution command enter or another chosen filtering option by using the and or from the right-click menu. It's got it out here. Right, number 1, prepare as filter. Right, selected, and then it's got it out there in the little query there. So let's go here and you can see 4343 apply as a column. By default, the package listed list pane provides basic information about each packet. You can use the right click analyze apply as column menu to add columns to the packet list. Once you click on a value and apply it as a column, it will be visible on the packet list. This function helps analysts examine the appearance of a specific value / field across the valuable packets in the captured file. You can enable / disable the columns shown in the packet list pane by clicking on the top of the packet list pane. It's got it out here, right? Apply as column, and there you go. Let's see, follow stream. Wireshark displays everything in packet, portion, size, however it is possible to reconstruct the streams and view the raw traffic as it is presented at the application level. Following the protocol streams help analysts recreate the application, yada, yada, yada. It's possible to view the unencrypted protocol data like usernames, passwords. This is the one I mostly use in the real world. I'll use the follow stream, like follow TCP, follow HTTP, or whatever to see the actual contents of that particular packet. It's very useful. You can use this right-click menu or analyze, follow TCP, yada, yada, yada. So streams are shown in a separate dialog box. Packets originating from the server are highlighted with blue. Those originating from the client are highlighted with red. So there you go, blue and red. Let's see here. We're almost done with this reading part. Once you follow a stream, Wireshark automatically creates and applies the required filter to view the specific stream. Remember, once a filter is applied, the number of the viewed packets will change. You will need to use the X button located on the right upper side of the display filter bar to remove the display filter and view all available packets in the capture file. Now let's go ahead and get to these questions here. Once again, we're going to use that same file, exercise.pcapng file, answer these questions. So let's go ahead and do that. Okay, once let's go back to packet number 4, which I have already done. And just a reminder to do that, you can click on go here, and then go to packet, right? And then type in 4, and then go to packet, right? It'll take you to the packet number. And it says to right click on the hypertext transfer protocol and apply as a filter. So let's go ahead and do that. Right click, and you're going to apply as filter, selected. Okay. And it says, what is the filter query? It's going to be HTTP. What is the number of display packets? Well, that's going to be 1089. As you see at the bottom, 1089 right here. Display 1089. So submit. Just go to packet number 33790. So let's go ahead and do that. To clear out this information here, hit that X like it said before, right? Go back to go to packet, and then we're going to go to that number there, 33790. So, right, and then go to packet, and it says follow the stream. What is the total number of artists? So let's go ahead and right click it, right, and then you're going to follow the HTTP stream. And wants to find the total number of artists. So let's go ahead and look through here, try to find that information. So to do that, we're going to search artist in this find, right? So click find, see what it does. It's got this artist.php in here. Let's see if there's anything of interest in here. Artist. So let's try maybe artist equals or something. Artist equal. Okay, got something. Artist equal 1. Here, so let's see if there's anything else. Artist equals 2 and artist equals 3. Looks like that's it. Okay, so 3. Type that in there. And let's see. It wants us to find the name of the second artist. So let's say artist equal 2. Hit find again. And let's see, Blade 3. Let's believe what it, yeah, Blade 3. So, or just Blade. So Blade. Sorry, the computer's going a little bit slow today. So Blade with the 3 at the end. Okay, awesome. And that should be it. So I'm going to go ahead and exit split view here, and we're going to take a look at the conclusion section. Conclusion, congrats. You just finished the Wireshark basics room. In this room, we covered Wireshark, what it is, how it operates, and how to use it and to investigate traffic captures. Want to learn more? We invite you to complete the Wireshark Packet Operations room to improve your Wireshark skills by investigating packets in depth. Awesome. So maybe we'll check out this Packet Operations room next or something. But I hope you guys enjoyed this video and got some kind of valuable information on it. Hopefully you're following along and paying attention to the information discussed. And if you got any type of valuable information from this video, be sure to hit that subscribe button, hit the like button on the video, and then hit the comment section below. Have you used Wireshark before? Have you used Wireshark via these methods that they're describing throughout these tasks? Have you done it using different techniques when it comes to investigations and such? Like I said, I mainly use that, follow TCP stream, and then for the actual filters, I will type those in manually usually. I don't use like the, click right or right click on it and then apply filters, what have you. But thank you for watching and have a good day. See you later. Hey everybody, this is WireDogSec. Just a quick reminder to subscribe to the channel and hit the notification bell. Once you hit the notification bell, be sure to set to all notifications so you know every time I post to the channel, upload a video, all that good stuff. Let's continue to grow our glorious community here. We are in the cyber trenches. We're not just reporting on it. Be sure to check out my channel as well. I have tons of videos that you can see here, over 300 videos ready for you to check out and learn something from. Be sure to review my posts. I'm frequently posting new things to my channel here, including jobs and everything related to that. Also, I have tons of playlists here that you can review, make it more convenient for you. Anyway, happy defending, happy hacking, enjoy the video. Hey everybody, welcome back to my channel. This is WireDogSec, back with another video for you guys. Today's video, we are in the SOC Level 1 Learning Path, Network Security and Traffic Analysis module. This is the Wireshark Packet Operations room. Learn the fundamentals of packet analysis with Wireshark and how to find the needle in the haystack. We're going to be covering various different items here. All right, starting from the statistics slash summary, and then protocol details, principles, protocol filters, advanced filtering, and then we're going to wrap it up and go over a summary of what we covered and learned with this room. As usual, if you don't have access to this room, if you're not a subscriber to this room, then you can just follow along with the video and then just take notes. All right, without further ado, let's go ahead and dive into it. Task 1 Introduction. This room, we're going to cover the fundamentals of packet analysis with Wireshark and investigate the event of interest at the packet level. It says take note that this is the second of the Wireshark room trio, and it's suggested that you complete the first room, which is called Wireshark the Basics, or you can check out my channel to see if I have a video of that. I'm pretty sure I do. And it says to practice and refresh your Wireshark skills before starting this one. In the first room, we cover the basics of Wireshark by focusing on how it operates and how to use it to investigate packet captures, traffic captures. In this room, we will cover advanced features of Wireshark by focusing on packet level details with Wireshark statistics, filters, operations, and functions. Okay, so there's a task VM. Go ahead and start that up, which I've already done, and I have to open up in another tab to make it bigger. So we're done with that. First task that we're going to actually take a look at things is going to be this statistics summary. So let's see what statistics is. This menu provides multiple statistics options ready to investigate to help users see the big picture in terms of scope of the traffic, available protocols, endpoints, and conversations, and some protocol-specific details like DHCP, et cetera. For security analysts, it is crucial to know how to utilize this statistical information. This section provides a quick summary of the process to PCAP, which will help analysts create a hypothesis for investigation. You can use the statistics menu to view all available options. Now start the given VM, open the Wireshark and exercise.pcapng file and go through the walkthrough. Okay, let's go ahead and flip over there. Here it is open right now. Now I'm going to go to file and then open, and then we're going to open up that PCAP file, which is this here. Okay, there we go. There's quite a lot of packets in here, so while that's loading up, let's go ahead and continue on here. Okay, so we're going to look at this statistics as soon as it uploads or loads the file in, and okay, it's done. So statistics right here, and here's the sub menu of it. They're going to take a look at things inside of here. So let's see what they're saying. Resolved addresses. This option helps analysts identify IP addresses and DNS names available in the captured file by providing a list of the resolved addresses and their host names. Note that the host name information is taken from DNS answers in the captured file. Analysts can quickly identify the accessed resources by using this menu. Thus, they can spot accessed resources and evaluate them according to the event of interest. You can use the statistics and then go over to the resolved addresses menu to view all the resolved addresses by Wireshark. So it's going to look something like this. Once you click on statistics and then look at that submenu, you'll see the resolved addresses. Okay, so let's go ahead and do that here. Statistics is open, and then resolved addresses, click that, and here we go. A lot of information here, so let's see if I can make this a little bit bigger. Okay. All right, so we have host information in here. It appears. Then we have ports over here in this tab here. Okay. You can also sort things. So we can sort by port numbers. All right, it's pretty nifty. Comments, nothing in here. So let's flip back over and continue on. Protocol hierarchy. This option breaks down all available protocols from the captured file and helps analysts view the protocols in a tree view based on packet counters and percentages. Thus, analysts can view the overall usage of the ports and services and focus on the events of interest. The golden rule mentioned in the previous room is valid in this section. You can right-click and filter the events of interest. You can use statistics and then protocol hierarchy to view this info. So let's go ahead and do that here. Let's go ahead and close this. Okay, statistics, and then protocol hierarchy. Okay, there we go. So a lot of information here to take in. Taking some good notes here. Also, you could probably use this on a different PCAP out there as well. I'll go at the end of the video. I'll show you a place where you can go ahead and take a look at PCAPs that you can analyze in like in a lab environment. Okay. So anyway, so there's a lot of information here. You got protocol packets, percentage packets, et cetera, et cetera. A lot of good information here so far. So let's flip back over. Okay. Conversations. This conversations represents traffic between two specific endpoints. This option provides the list of the conversations in the 5 base formats: Ethernet, IPv4, IPv6, TCP, and UDP. Thus, analysts can identify all conversations and contact endpoints for the event of interest. You can use the statistic, then conversation menu to view this information. So let's go ahead and flip back over once again and take a look. Okay, so statistics and then conversations. There we go. It's loading up here. Some more good information inside of here, so you can scroll over and take a look at it. Packets and bits and durations, stuff like that. And you can break it down here: IPv4 stuff, IPv6, TCP, and UDP. So a lot of good information here. And it looks like you can play around with some things down here as well, flip on and off as needed. Let's see here. Endpoints. The endpoints option is similar to the conversation option. The only difference is that this option provides unique information for a single information field: Ethernet, IPv4, etc., etc. Thus, analysts can identify the unique endpoints in that captured file and use it for the event of interest. You can use the statistics endpoints menu to view this info. Wireshark also supports resolving MAC addresses to human readable format using the manufacturer name assigned by IEEE. Note that this conversation or this conversion is done through the first 3 bytes of the MAC address and only works for the known manufacturers. When you review the Ethernet endpoint, you can activate this option with the name resolution button in the lower left corner of the endpoint. So once we get in there, to look something like this here. So let's go ahead and follow along. Close out of this here. Okay, and we need to go to statistics again, endpoints. Okay, well that loads up. So this is what it looks like normally. You have these different tabs up here we take a look at, right? It gives you like country stuff, information like that. So it's some pretty good info inside of this already. Okay, then name resolution, like that. See how it converts everything there? So if you unclick it, it's back to just regular MAC addresses, and then it transforms it into the actual manufacturer name and such for the ones that actually have one for them. So you got Xerox, IBM, Sophos, and so on and so forth. All right, pretty nifty there. Name resolution is not limited only to MAC addresses. Wireshark provides IP and port name resolution options as well. However, these options are not enabled by default. If you want to use these functionalities, you need to activate them through the Edit Preferences Name Resolution menu. Once you enable IP and port name resolution, you can see the resolved IP addresses and ports names in a packet list pane, and also will be able to view resolved names in the conversations and endpoints menus as well. Okay, so if we wanted to do that, we got to go to Edit and then Preferences, Name Resolution. So let's just see what it looks like. Let me close out of this here. Okay, Edit, then Name Resolution. All right, there we go. And then we want to resolve network IP addresses. I think it's the only one I selected. Resolve transport names as well. It's the other one. So let's go ahead and select both of these here. Hit OK. All right, there we go. See, it changed some things here. Now, if we go back to what we were looking at here, I think endpoints I said was one of them we could take a look at, and then IPv4. So let's see, yeah, making sure we're following along here. Yeah, conversations and endpoints. So it'll resolve those names there. If you want to go ahead and flip that switch on. And this is what it looks like here, as we just saw in real time. It transformed into this here. So there's the difference as it looks. Okay, this endpoint menu. All right, pretty neat, but I don't see. Let's see. So there's actually did it, but okay, maybe I am. Okay, there we go. Right there. Now it's doing it. There we go. That's pretty neat. That's pretty neat. Okay, I'm gonna go ahead and close that out. And then it said the other one we could take a look at was the conversations, and we have it down here as well. So here's what it looks like normally, and then if we flip that switch on, there we go. Okay, pretty neat. Let's go ahead and continue on. Besides name resolution, Wireshark also provides an IP geolocation mapping that helps analysts identify the map's source and destination IP addresses, but this feature is not activated by default. It needs supplementary data like GeoIP database. Currently, Wireshark supports MaxMine databases, and the latest versions of the Wireshark come configured MaxMineDB. However, you still need MaxMineDB files and provide the database path to Wireshark by using edit preferences, name resolution, MaxMine database directory menu. Once you download and indicate the path, Wireshark will automatically provide geo information or geo IP information under the IP protocol details of the matched IP addresses. That's pretty neat. So if you get those databases, you'll get some additional information like this. Okay, endpoints to geo IP view, and if we just want to follow along with this, so edit preferences, name resolution. So let's go ahead and get out of this. Okay, name resolution, and then we had to go to what was next? MaxMine database. Right there. So if you go to edit here, then you go and select it. So it looks like some's already in there. All right, cool. Which would explain probably why we were seeing these things transform like that or convert over like that. All right, yes, that's why we were seeing this in there. Okay, that's pretty cool. All right, so you need an active internet connection to view GeoIP map. The lab machine doesn't have an active connection. Okay, I don't think we'll need that anyway. So there's some questions here. Be sure to pause the video, try to answer these questions yourself, come back to the video, and then we will step through it together. Hey everybody, this is WireDogSec. Just a quick reminder to subscribe to the channel and hit the notification bell. Once you hit the notification bell, be sure to set to all notifications so you know every time I post to the channel, upload a video, all that good stuff. Let's continue to grow our glorious community here. We are in the cyber trenches. We're not just reporting on it. Be sure to check out my channel as well. I have tons of videos that you can see here, over 300 videos ready for you to check out and learn something from. Be sure to review my posts. I'm frequently posting new things to my channel here, including jobs and everything related to that. Also, I have tons of playlists here that you can review, make it more convenient for you. Anyway, happy defending, happy hacking, enjoy the video. Let's take a look at these questions. Investigate the resolved addresses. What is the IP address of the host name that starts with BBC? So let's go ahead and flip back over here, and we're going to go to statistics and resolved addresses. All right, and just going to make this a little bit bigger. All right, so BBC, just go ahead and type it in here. And we can see here's the IP address here. So go ahead and plug that in. Next one, what is the number of IPv4 conversations? All right, so we're going to go ahead and check out conversations. Okay, IPv4, and we have 435 there. Next one says, how many bytes, kilobytes, were transferred from the micro ST MAC address? And we're going to take a look at endpoints here. Okay, once you have that sorted out, you're going to need to click this name resolution. Remember, it converts this into the actual name of the manufacturer. And we need to go over to Ethernet. Make sure the right tab here. Okay, so let's go ahead and find that in here. And right there is what we need. And we have 700 or 7,474. Okay, so we're done with that one. What is the number of IP addresses linked with Kansas City? All right, so once again, let's go ahead and take a look inside of here, IPv4, and then we're going to scroll over to the city, and then we're going to sort this, and then for Kansas City. All right, Kansas City, so we have 1, 2, 3, and 4 for our answer there. Next one says, which IP address is linked to the BlickNet AS organization? So we're going to go ahead and scroll over to the AS organization, and once again, we're going to sort it and then find that organization. So it's sorted, so now we need to find it. So it should be in the B's. There we go. Now we're going to scroll back over to the IP addresses, and then we're going to uncheck this name resolution, and then here's the IP right there. It's the one we need to plug in there. So we're done with that task. Task number 3, we're going to look at statistics and protocol details, IPv4 and IPv6. Up to here, almost all options provided information that contain both versions of the the IP addresses. The statistics menu has 2 options for narrowing the statistics on packets containing a specific IP version. Thus, analysts can identify and list all events linked to specific IP versions in a single window and use it for the events of interest. You can use the statistics IPv6 statistics menu to view this. So let's go ahead and hop over there and do that. Close out of this statistics, but then let's go ahead and find that. Okay, so we have IPv6 and IPv4 down here. All right, so that's good to know. Okay, and it looks like they went to IPv4 and then all addresses, and they looked at various different options inside of here. So if we just want to play around with it, let's just try to follow along. So we'll click all addresses first to get some information in here. Various different tabs you can take a look at. Okay, so that's pretty neat. Close this out. I'm going to go back to it. And then we're going to do the same for destination and ports. Okay, that's pretty cool there. All right, nice. Let's see. DNS. This option breaks down all DNS packets from the captured file and helps analysts view the findings in a tree view based on packets, counters, and percentages of the DNS protocol. Thus, analysts can view the DNS service overall usage, including R code, opcode, etc., and use it for the event of interest. You can use the statistics, then DNS menu to view this information. All right, so this is pretty much, a lot of this is just straightforward, right? Just go to statistics and then go to whatever you're looking for inside of your conversations, endpoints, etc. So we're going to click on DNS. So scroll through here, we can see what they're talking about: R code, OP codes or opcodes, query response, all that good stuff inside of here. Okay, that's pretty interesting there. And HTTP, this option breaks down all HTTP packets from the captured file and helps analysts view the findings in a tree view based on HTTP protocol. So pretty much a similar thing. All right, so same thing for DNS, we're going to do the same thing for HTTP. So statistics and then HTTP to view this information here. So let's go ahead and follow along. Okay, and let's click on packet counter. See this information inside there. Awesome. And we're going to take a look at another one. Cool. Now, obviously, you're going to need to spend some time to go through all this stuff here and make sure you familiarize yourself with this particular application and these menus and options and such. Okay, so they already have everything here in these screenshots, as we saw as well in the lab environment. And we have question time as well, so be sure to pause the video, go through these questions yourself, and try to answer them and come back to the video. All right, let's take a look at these questions. What is the most used IPv4 destination address? Let's flip back over to the VM, statistics, IPv4 statistics down here, and then destination and ports is what we need. Now this does take about a minute or two to load up all the way. As you can see, it's loading very, very slowly. All right, now while that's loading up, the other website I was talking about was this malware traffic analysis that you can take a look at. They have various different PCAPs in here that you can play around with in a lab environment. So just be careful as you're going through these. Okay, they even give you some information on how to go through these exercises, I believe. So let's go ahead and flip back over to our VM. Okay, it's almost done. So once it's done, I'm going to click count up here. And then you can see that this is going to be here. This 10.100.1.33 should be what we are looking for. Next one says, what's the max service response or request response time of the DNS packets? So we're going to go to and look at the DNS section of statistics. All right, so we're going to flip over to statistics and then DNS. Okay, so once it's fully loaded, I'm not sure if this is needed, but I went ahead and just sorted this, and then service stats, and then the response or request response is going to be this here. So the max value is going to be this 0.46, etc., etc., etc. So that's going to be our answer for that one. And what is the number of HTTP requests accomplished by RAD www.msn.com. Flip over to the VM. Now we want to go to statistics and then HTTP, then requests, and I'll bring up this other little box here. Okay, make it a little bit bigger. All right, now we're gonna have to scroll over a little bit to find that. I'm just gonna drag it over. Okay, try to compress things for a little bit here. Okay, so now we need to go and find rad inside of here. Okay, there we go, rad.msn.com. And we see count here is going to be 39, and that's what we are looking for. So go ahead and plug that in, and we are done with that. All right, so we're done with that. Task number 4, look at principles, packet filtering. In the previous room, Wireshark the basics, we covered packet filtering and how to filter packets without using queries. In this room, we will use queries to filter packets. As mentioned earlier, there are 2 types of filters in Wireshark. While both use similar syntax, they are used for different purposes. Let's remember the difference between these 2 categories. So we have captured filters and display filters, or filters. Captured filters, this type of filter is used to save only a specific part of the traffic. A display filter, this type of filter is used to investigate packets by reducing the number of visible packets and is not changeable during the capture. Note, you cannot use the display filter expressions for capturing traffic and vice versa. Okay, so you can just use one or the other according to this, from my understanding. The typical use case is capturing everything and filtering the packets according to the event of interest. Yes, that's typically what I do. If we're going to do a live capture, capture it first, save it as a PCAP file, and then start analyzing it afterwards with the filters. Only experienced professionals are use captured filters and sniff traffic. This is why Wireshark supports more protocol types and display filters. Please ensure you thoroughly learn how to use captured filters before using them in a live environment. Remember, you cannot capture the event of interest if your capture filter is not matching the specific traffic pattern you're looking for. All right, capture filter syntax. These filters use byte offsets, hex values, and masks with Boolean operators, and is not easy to understand / predict the filter's purpose at first glance. The base syntax is explained below. So you have scope, hostnet, port, and portage, direction, source, destination, protocol, ETH, WLAN, etc. Sample filter to capture port 80 traffic. So this is something that you could use. They're showing you what it looks like if you were to use this. So TCP and then port 80 is where you're going to be filtering for. You can read more on capture filter syntax here and here. So check those out to familiarize yourself with that. A quick reference is available under capture and then capture filters menu. So if we want to flip back over there, and it was under capture and then capture filters right here. Okay, that's pretty neat. Okay, display filter syntax. This is Wireshark's most powerful feature. It supports 3,000 protocols and allows conducting packet level searches under the protocol breakdown. The official display filter reference provides all supported protocols breakdown for filtering. Sample filter to capture port 80, TCP.port equals to 80. Pretty neat. Wireshark has a built-in option, display filter expression, that stores all supported protocol structures to help analysts create display filters. We will cover the display filter expression menu later. Now let's understand the fundamentals of the display filter operations. A quick reference is available under Analyze and then Display Filters. So if we want to take a look at that, close out of this. Okay, Analyze and then Display Filters. Pretty neat. It has these in there for you, right? You can also plug them in here. It says apply a display filter. So there you go with that. Comparison operators. You can create display filters by using different comparison operators to find the event of interest. The primary operators are shown in the table below. So English, C-like, description, and example. So EQ equals to C-like, and then description equals. And then here's an example, and then you can see the rest here, not equals, greater than, less than, etc., etc. So pretty neat, something to take note of here. Notes, Wireshark supports decimal and hexadecimal values in filtering. You can use any format you want according to the search you will conduct. Logical expressions. Wireshark supports Boolean syntax. You can create display filters by using logical operators as well. So once again, you have and, or, and not, and this is how you can do them inside of Wireshark here. So a lot of things you can do inside these particular filters and such. Packet filter toolbar. The filter toolbar is where you create and apply your display filters. It is a smart toolbar that helps you create valid display filters with ease. Before starting To filter packets, here are a few tips. Packet filters are defined in lowercase, so remember that. Packet filters have an autocomplete feature to break down protocol details, and each detail is represented by a dot. Packet filters have a 3-color representation explained below. Right, so green, valid filter. So green, good, red, bad, and valid filtered, and yellow, warning filter. Filter works, but it's unreliable, and it's suggested to change it with a valid filter. And this is an example of what they look like here. So green means go or good, red means bad. Change your syntax, check your syntax, and then yellow is a warning filter. All right, pretty straightforward so far. Filter toolbar features are shown below here. All right, so it's just giving an example of other options of this like autocomplete, right? So if we want to try that out, let's just do IP, and it gives you a breakdown here. So this has come up quite a bit from back in the day. I don't think it even had this autocomplete or anything like that. So this is pretty fancy stuff here. Pretty cool. We covered lots of principles and syntax. Let's put these into practice and start filtering the next task. Awesome. So task number 5, looks like we're gonna get into practical app. Protocol filters. As mentioned in the previous task, Wireshark supports 3,000 protocols and allows packet level investigation by filtering the protocol fields. This task shows the creation and usage of filters against different protocol fields. IP filters. Help analysts filter the IP traffic according to the IP level information from the packets. This is one of the most commonly used filters in Wireshark. These filters filter network level information like IP addresses, version, etc., etc., etc. The common filters are shown in a given table here. So you have filter and then the description IP, show all IP packets, IP.address equal to or equals the IP address here. And then you can see the rest as well. So you can do subnets and then source IP, destination IP. So a lot of neat stuff here. Make sure you're taking notes. IP.address or ADDR versus IP.source/IP.destination or DST. Okay, and explains it here. All right, so that's good to go. Pretty interesting stuff here so far. So you can do a lot of stuff with Wireshark. It's very, very versatile and robust. So TCP and UDP filters. TCP filters help analysts filter the traffic according to protocol level. Okay, these filters filter transport protocol level information like source, destination port, sequence number, etc., etc. So you can filter on TCP, and then another one you can filter on UDP ports. It's just pretty much straightforward, self-explanatory. You can see here more information in these tables if you want to try these particular filters out yourself. All right, so I'm just going to go ahead and just grab this one, I guess, and plug it in here just as an example. All right, hit enter, and it's loading. Now I just filtered on port 80, right? And it's going to show me all that information. And I'm going to clear it out here by clicking this X. Okay, now I'm back to what it was before. All right, so pretty much straightforward here. Application level protocol filters, HTTP and DNS. So basically the same thing here. You're filtering on these protocols instead of particular ports or IP addresses, okay? You can see the table here that gives you some inkling of what they look like, right? So you can just take these as your notes because you're probably going to use them later on or sometime in your IT career. You'll come across Wireshark and needing to analyze PCAPs. So this is very useful information here. Display filter expressions. As mentioned earlier, Wireshark has a built-in option that stores all the supported protocols, which we saw earlier. When an analyst can't recall the required filter for a specific protocol or is unsure, the display filter expressions menu provides an easy-to-use filter display, builder guide. So analyze display filter. All right, so let's just go ahead and look at it again real quick. Analyze display filters. Okay, let's just select TCP. Actually, let's just go to HTTP only since we just did something similar. Okay, and I believe that's it, right? Does it? Okay, so it's supposed to, let's go ahead and read on here. It's impossible to memorize all the filters, okay? Display filter expression menu shows all protocol fields, accepted values. Note that it will take time and require practice to master creating filters and learning the protocol. So if you want to use this, go to the display filter expression and select whatever you want to use, and then select the other criteria accordingly, right? So it's basically like a wizard of building out these filters, right? And then it breaks it down. Here you click OK, and then it'll show up in that display bar, right? So let's do this again. Expression is the one we need to click on. Okay. Now we have various different ones we can choose from. So, wow, there's a ton in there. So let's just try HTTP. Okay, there we go. There's a lot in there. We'll just select this one. Okay, and we'll just leave it like it is present. Okay, and then click OK. Now we have it up there. And you can hit enter or hit this here to run it. And now we're just filtering on HTTP traffic. So that's pretty cool that's in there. Note, the first room introduced the coloring rules. Now you know how to create display filters and filter the events of interest. You can use the view coloring rules menu to assign colors to highlight your display filter results. Awesome. So once again, pause the video and then answer the questions yourself, then come back to the video and we will continue on. What is the number of IP packets? Now, remember, we can filter on that specific information using that display filter. So let's go ahead and do that. I have IP already plugged in there. So I'm just going to hit this arrow here, hit enter on it, and then you should see down here where it says displayed. That should give us our answer. As soon as it loads, it wants to lag a little bit. So 81,420 is going to be our answer there. Next one says, what is the number of packets with a TTL value less than 10? Once again, you can use the filtering options, and if you need help with this, remember we can go always to this analyze and then display filter expressions. Help us build out that specific information. So if we want to go in and type it in, TTL. So if it's not in here, it's just going really slow. But anyway, all right, since this is going to lag, anyway, you can use this display expression to build out your queries, and I already have it here. So I have IP.ttl, and then less than 10 is going to be what we're looking for here. So I'm just going to copy and paste this over. And once again, it has this auto filter as well. So if you want to just build it out this way, you could do that. Okay, so this is an example IP.ttl, right? Then less than 10. Enter. Okay, once it's finished running, it should be down here at 66, should be our answer for displayed. Next one is what is the number of packets which uses TCP port 4444? So once again, use those filters that we learned about earlier up here, right? You can filter on those ports and everything. So that's exactly what you're going to do here. So I'm going to go ahead and just grab it out of here. So I already have it ready. So TCP.port is going to be equal to or equals 4444. Okay. So I'm going to delete all this out and just paste it in. This is going really slow today. It's very annoying. Hit enter. So once it's done, you're going to get the answer down here, displayed 632. So that's our answer there. And next one is what is the number of HTTP GET requests sent to port 80? So once again, use those filtering, use that builder to filter it out, or you could just use autocomplete. Right, so anyway, this is what you should get, or something similar to this, http.request.method, right? Because we're looking for the method, and the method is going to be get, right? Make sure you have these double quotes in there for the string, and then you're going to combine it with the and then the tcp.dest port, because that's the destination port, because it's asking for a request sent to port 80, and then it's going to be equal to 80. So there we go there. I'm just going to copy and paste it over. Enter. Okay, so once it's done, you can see there at the bottom it displayed 527 should be what we're looking for. And the last one is what is the number of type A DNS queries? Now, once again, you're going to need to combine these, right? So first off, you're going to look for the DNS queries. If we scroll up a little bit, you can see what they're talking about here, right? So show all DNS A records, and then show all DNS requests, DNS responses. And if you take a look at my example here, all right, so we're looking for A, and then we're combining it with this flag.response equals to 1, because you're going to be looking for those. You need to find the responses is what we're looking for in these, or you need to filter those out is what I should say. Okay, so paste this in. Once it's finished running, we should get our answer here shortly. 51 is what we're looking for here. So there we go. Task number 6, advanced filtering. So far, you have learned the basics of packet filter operations. Now it's time to focus on specific packet details for the event of interest. Besides the operators and expressions covered in the previous room, Wireshark has advanced operators and functions. These advanced filtering options help the analyst conduct an in-depth analysis of an event of interest. So once again, here's some filters, contains, all right, and it explains what it is here. Comparison operator, description, search of value inside packets. It is a case sensitive and provides similar functionality to the find option by focusing on a specific field. Example, find all Apache servers. Workflow, list all HTTP packets where packets server field contains Apache keyword. Usage, HTTP.server contains Apache. And this is an example of what they're talking about here. So this is very useful. And then you have matches, which explains what this is as well. Comparison operator, search a pattern of regular expression, case insensitive. Example, find all .php and .html pages. List all HTTP packets where packets host fields match .php or .html. And here's an example of the usage here, http.host matches. Then inside these double quotes here, you have the backslash dot, and then inside open and close parentheses, PHP, pipe, HTML. All right, in this example, what it looks like here, you have the filter in membership, search a value, or field inside of a specific scope or range, find all packets, etc., etc. And here's an example of what that looks like here. So you're looking for a specific range or scope in this. So they're looking for ports in 80.443 and 80.80, right? And that should pull back that particular information. Next one is upper. So it says that convert a string value into uppercase, find all Apache servers, and Apache's in all caps. Here's an example of that looks like upper, and then http.server contains Apache. Okay. Lower, same thing, just opposite. All right. String, convert a non-string value to a string, find all frames with odd numbers, convert all frame number fields, string values, and list them. List frames and with odd values. Okay, so string looks pretty useful here. Bookmarks and filtering buttons. We've covered different types of filtering options, operators, and functions. It is time to create filters and save them as bookmarks and buttons for later usage. As mentioned in the previous task, the filter toolbar has a filter bookmark section to save user-created filters, which helps analysts reuse favorite/complex filters with a couple of clicks. Similar to bookmarks, you can create filter buttons ready to apply with a single click. Some really fancy and interesting things. I don't think I've ever done this level of filtering inside of Wireshark. I usually keep it to the basic level at the most part, and maybe a little bit um, further than that. But I've never gotten into like bookmarks and filtering buttons and stuff like that. I'm not in Wireshark on a daily basis or anything like that, but this is very interesting stuff here, and it's just walks you through the steps of creating bookmarks, right? So basically, just saving these particular queries, filters, what have you. So it says add display filter button, click that plus sign, and then inside of here, select the criteria, and then it says odd frames. It's just find all frames, yada, yada, yada. So I guess that's the description you can plug in there. So let's see here. Does it even let me do it? Let's see. Okay, we'll go back to that later if we need to use this. But let's go ahead and continue on. Profiles. Wireshark is a multifunctional tool that helps analysts to accomplish in-depth packet analysis. As we covered during the room, multiple preferences need to be configured to analyze a specific event of interest. It is cumbersome to rechange the configuration for each investigation case, which requires a different set of coding rules and filtering options or filtering buttons. This is where Wireshark profiles come into play. You can create multiple profiles for different investigation cases and use them accordingly. You can use the Edit Configuration Profiles menu or the lower right bottom of the status bar profile section to create, modify, and change the profile configuration. So if you want to do that, you can do it like so. So let's just follow along here. And it says the first option, edit, and then configuration profiles. So edit, configuration profiles, or Control Shift A for short. And there you go here. So that's pretty neat. Saves you a lot of time, right? If you're going to be using Wireshark on a daily basis. Okay, once again, question time. Pause the video, go through these questions, answer them, come back to the video, and then we will go through it together. Let's take a look at these questions here. Now, there are hints here, and I use several of these hints because, like I said, I'm not an expert in Wireshark, and I'm not in Wireshark all the time or using these fancy buttons or advanced areas here inside of Wireshark. But anyway, let's get to it. Find all Microsoft IIS servers. What is the number of packets that did not originate from port 80? So let's flip back over here, and I'm going to check my notes. Now we're going to look for http.server contains IIS and does not equal source port 80 is what this one is saying here. So I'm going to copy this, paste it over, enter, then down for displayed, should get our answer 21. Next one, find all IIS servers. What is the number of packets that have version 7.5? So this one's similar to what we just did, except for we're changing the last part of it to http.server matches 7.5 instead of double quotes. Okay, so clear all this out. Then it says displayed 71 for our answer there. And then it says, what is the number or the total number of packets that use ports 333 and 44449999? Okay, now we can use that range or scope, whatever they're talking about earlier, right? So that's exactly what I did here, tcp.port in this range or scope. So I'm going to plug that one in to get this answer here. Hit enter. Once it's finished running, it should be our answer there, 2235 for that one. And the next one, we're going to look for what is the number of packets with even TTL numbers. Now, like I said, this one's a bit tricky for me, but this is the way I did it here. So string IP.ttl, then matches 24680, and then $ at the end there. So you can check the hint as well to give you some things to use here. So they're using this regex value. Okay, so I'm going to plug this in. Okay, so once that's finished running, we should get our answer there for the number of packets. Okay, so 77289 for displayed. The next one is we're gonna look for checksum. We're gonna switch over to the checksum control profile, and then what is the number of bad TCP checksum packets? Now this one, you'll have to use that expression. At least I did. So I already flipped over. So from default, if I want to flip back, here's the default. Flip back over to the checksum control. It's finished. You can go to the, I believe it's under Analyze, and then Display Filter Expression, and then you can search on it here. This one can take a bit to look for, so I'm gonna look for TCP. I think it was .checksum. So let's see, checksum. There we go. So TCP is what we need here, and then for this one, we need the status. So tcp.checksum.status, what we're looking for here, and then bad. So this is already set for us, and then this is what's going to plug it into the filter. Hit OK. And I need to get rid of this stuff first. So delete all that. Now enter. So once it's finished running, we should get our results back. Okay. And that should be our answer, 34,185 for the displayed. Okay, and then the last one here says, use the existing filtering button to filter the traffic. What is the number of display packets? Now this one's easy. You just go over here to this button where it says GIF/JPEG with HTTP 200. Click that. And first, let's clear all this stuff out. Then we'll click that button. Enter. Okay, so there's our answer there. Display is 261. So we're done with that. And we're going to close it out to conclusion. I just finished the packet operations room. We covered statistics, filters, operators, and functions. Want to learn more? I invite you to complete the Wireshark Traffic Analysis room to improve your Wireshark skills by investigating suspicious traffic activities. That's probably going to be our next video, actually. But um, like I said at the beginning of the video, there is this malware traffic analysis website here. I'll have the link in the description if you want to do some more lab work or hands-on keyboard experience dealing with actual PCAP files that were found out in the wild. I recommend taking a look at that to familiarize yourself better with Wireshark. So let's go ahead and close this out. Conclusion complete. Now, if you enjoyed this video, you want to support the channel, be sure to hit that like button, comment, subscribe with that notification bell so you know every time I upload a new video to the channel. As always, thank you all for your continued support. Have a nice day, and I will see you later. Hey everybody, this is WireDogSec. Just a quick reminder to subscribe to the channel and hit the notification bell. Once you hit the notification bell, be sure to set to all notifications so you know every time I post to the channel, upload a video, all that good stuff. Let's continue to grow our glorious community here. We are in the cyber trenches. We're not just reporting on it. Be sure to check out my channel as well. I have tons of videos that you can see here, over 300 videos ready for you to check out and learn something from. Be sure to review my posts. I'm frequently posting new things to my channel here, including jobs and everything related to that. Also, I have tons of playlists here that you can review, make it more convenient for you. Anyway, happy defending, happy hacking, enjoy the video. Hey everybody, welcome back to my channel. This is WireDogSec, back with another video for you guys. Today's video, we are in TryHackMe, SOC Level 1 Learning Path, Network Security and Traffic Analysis module. This is the Wireshark Traffic Analysis room. Learn the basics of traffic analysis with Wireshark and how to find anomalies on your network. Now, this is a paid for room, but if you don't have the membership for TryHackMe, it's fine. You can just watch the video, follow along, and just take notes where needed. Okay, and we're going to get to quite a few things here. We look at nmap scans, ARP poisoning, tunneling traffic, encrypted protocols, decrypting HTTPS. Sounds pretty interesting. We got some bonus items here: hunt clear text credentials, actionable results, and we're going to wrap it up with the recap over what was covered in this room and what we learned in this room. Without further ado, let's go ahead and dive into it. Task 1 Introduction. In this room, we will cover the techniques and key points of traffic analysis with Wireshark and detect suspicious activities. Note that this is the third and last room of the Wireshark room trio, and is suggested to visit the first two rooms stated below to practice and refresh your Wireshark skills before starting this one. So check out these two rooms here before you get on this one, according to what they're saying here. Also, check out my channel. I probably have videos over these two rooms that you can go and reference real quick before you dive into this one here. Since the first two rooms, we covered how to use Wireshark and do packet level searches. Now it's time to investigate and correlate packet level information to see the big picture in the network traffic. Like detecting anomalies and malicious activities, for a security analyst, it is vital to stop and understand pieces of information spread in packets by applying the analyst's knowledge and tool functionality. This room will cover investigating packet level details by synthesizing the analyst's knowledge and Wireshark functionality for detecting anomalies and odd situations for a given case. Okay, so they have the task VM here. Make sure to start it up. I've already done so. They have split screen available, but I'm going to just use a different tab here. So let's go ahead and do that real quick. Show split screen, and then let's go ahead and open up the new tab, view full screen here. Okay, so we're ready to go here. We've got our exercises folder down there, and there's Wireshark. So I'm going to go ahead and get this spun up real quick. Flip back over, minimize this. All right, let's go ahead and continue on. Task number 2, we're going to talk about nmap scans. Nmap is an industry standard tool for mapping networks. Basically, it's a network scanner. Okay, this is well known in the cybersecurity community. You can use this as a port scanner, network scanner, what have you. It'll give you all types of information based on what kind of nmap scans that you use. So they have TCP connect scans, SYN scans, and UDP scans. Says it is essential to know how nmap scans work to spot scan activity on the network. However, it is impossible to understand the scan details without using the correct filters. Below are the basic filters to probe nmap scan behavior on the network here. Also, check out my channel. I'm pretty sure I have videos over nmap scans if you're interested in that. So we have TCP flags in a nutshell. So notes, and they have Wireshark filters on the side here. Global search, just type in TCP, UDP into that display filter, as we saw in the previous video. Only SYN scan, SYN flag is set, the rest of the bits are not important. So it's how you do those here. So this is pretty much straightforward here. Okay, gives you the definition of it over here, and then on the right side it'll tell you what you need to plug into the Wireshark display filter as we go through this room here. All right, so be sure to check out these and take notes of what each filter consists of in order to help you progress throughout this room and also in your career, because you'll probably use these filters at some point if you're going to be utilizing Wireshark here. TCP scans, TCP connect scan in a nutshell, relies on three-way handshake, needs to finish the handshake process, usually connected with nmap-st command, that's true, used by non-privileged users, only option for a non-root user, usually has a window size larger than 1024 bytes. As request, expects some traffic or some data due to the nature of the protocol. It'll complete that three-way handshake. Now, this one is, from my experience, safer than the send scan because the send scan leaves it open, whereas this will complete the entire three-way handshake, right? So if you have older devices on the network, just be careful of using that send scan because it could knock over something because it's not able to complete that three-way handshake. So anyway, open TCP ports. You have SYN, SYN-ACK, and ACK. Okay, open TCP port, SYN, SYN-ACK, ACK, ACK, reset, ACK, and then close TCP port, SYN, reset, and ACK. The images below show the three-way handshake process of the open and close TCP ports. Images and PCAP samples are split to make the investigation easier and understand each case details. So here it is right here. They're talking about three-way handshake. You got the SYN, you have the SYN-ACK, you have ACK, and then the reset ACK at the end there. All right, and then it says close TCP port connect. So we have SYN and then reset and ACK again. It says the above image provides the pattern and isolated traffic. However, it is not always easy to spot the given patterns in big captured files. That's true. Therefore, analysts need to use a generic filter to view the initial anomaly patterns, and then it will be easier to focus on a specific traffic point. The given filter shows the TCP connect scan patterns in a captured file. So this is what they're using here. TCP flag SYN equal to or equals 1 and TCP flags ACK equal to 0 and TCP window size 1024 as we read about earlier, and this is what it looks like here. They're putting that in that display filter so we can clear out a lot of this other noise that they don't need to see. SYN scans. TCP SYN scan in a nutshell doesn't rely on three-way handshake, as I stated before, usually connected with nmap SS, used by privileged users, usually have a size less than or equal to 1024 bytes as the request is not finished and doesn't expect to receive data. That's right. And this is what it looks like here, open TCP port. So SYN, and you have the SYN ACK, and you have that reset, right? Because it doesn't complete that three-way handshake. Then close TCP port, SYN, and then reset ACK. And this is what it looks like inside of Wireshark itself. Okay, pretty straightforward here. Close TCP port. And then here's the filter for that in the captured PCAP file. So if you want to filter that traffic, you use something like this, as we just read about earlier. Okay, pretty straightforward. UDP scans. UDP scan in a nutshell doesn't require a handshake process, right? Because it's UDP. No prompt for open ports. ICP or ICMP error message for closed ports, usually connected with nmap-su command. And it says here UDP packet and then closed UDP packet and ICMP type 3, code 3 message, destination unreachable, port unreachable. Here's an example of what it looks like inside of Wireshark. Looking at a PCAP file. So the above image shows that the closed port returns an ICMP error packet. No further information is provided about the error at the first glance. So how can analysts decide whether this error message belongs? The ICMP error message uses the original request as encapsulated data to show the source/reason of the packet. Once you expand the ICMP section in the packet details pane, you will see encapsulated data and the original request as shown in the image below. That's right, we know about this here, right? If you ever played around with Wireshark, which means that once you click on an item or a packet inside of here at the top, you can see more information down here, typically in the bottom panel there, as they're showing here. And it goes into some more details of what we just read about here, ICMP packets, encapsulated data down here, okay? The given filter shows the UDP scan patterns in a captured file, and this is what it looks like here. Remember they're talking about that close code, which we read about earlier, type 3 code 3 message, right? Okay. Detecting suspicious activities in chunked files is easy and a great way to learn how to focus on the details. Now use the exercise files to put your skills into practice against a single capture file and answer the questions below. All right, so once again, as usual, be sure to pause the video, try to answer the questions yourself, comment to the video, and then we will continue on. Hey everybody, this is WireDogSec. Just a quick reminder to subscribe to the channel and hit the notification bell. Once you hit the notification bell, be sure to set to all notifications so you know every time I post to the channel, upload a video, all that good stuff. Let's continue to grow our glorious community here. We are in the cyber trenches. We're not just reporting on it. Be sure to check out my channel as well. I have tons of videos that you can see here, over 300 videos ready for you to check out and learn something from. Be sure to review my posts. I'm frequently posting new things to my channel here, including jobs and everything related to that. Also, I have tons of playlists here that you can review, make it more convenient for you. Anyway, happy defending, happy hacking, enjoy the video. All right, let's take a look at these questions. Use the desktop exercise PCAPs in map exercise.pcapng file. What is the total number of the TCP Connect scans? Since we already know we're looking for TCP Connect scans, we have a filter for that. So let's go ahead and bring it up here. And you can see that it should be this one as we read about earlier. So I'm gonna go ahead and grab it out of here. We're gonna need this whole thing here. All right, so I'm gonna hit Control C to copy that and plug it into display filter here. I already have the packet loaded up, as we can tell. And then at the bottom here, it says this displayed 1000. So that should be our answer there. Next one says, which scan type is used to scan the TCP port 80? So once again, you can use that same filter and then just add this and TCP.port equals 80, since that's the port that we were looking for. So let's go ahead and plug that in here and take a look. And the only one that comes back is this one here. All right. So that should be our answer, is going to be TCP connect for that one, right? Because we're looking for the total number of TCP connect scans up above here. And also you can go to, I believe, this here to see that information. So you have SYN, ACK, and then there's the receipt packet at the end. So that's a three-way handshake for the TCP connect. All right, so that takes care of that one. The next one is, how many UDP close port messages are there? Now, I'm going to go ahead and grab that filter out of here, and that's going to be looking for these codes here, right? So let's go and plug that in, enter. There we go. And now we should have 1083 as our answer there, as we can see there at the bottom for displayed. As we read about earlier, it was looking for those error codes inside of here for destination unreachable, right? So the next one says, which UDP port in the 55 to 70 port range is open? Now for this one, you might take a look at my other video where we talked about how to look for port ranges and such. But anyway, we can see here that we can use this particular filter to search for that criteria. So we're looking for UDP ports, and then in this range, which is going to be 55 to 70, right inside of these open and close curly braces here. And it explains it here. Says the ICMP error message uses the original request as encapsulated data to show the source/reason of the packet. Once you expand the ICMP section in the packet details pane, you will see the encapsulated data in the original packet request as shown in the below image. So we saw that earlier, right? So let's go and plug it in, and we'll take a look at those error codes in here to get this particular information. Okay, so we have these two errors here, destination unreachable. So if we click in there, and then we take a look down here at the bottom here, you can see destination unreachable. They can see other information here for the IP address and destination it's going to. All right, and you can see that it's linked to this 123, right, for the destination. So that one's going to belong to this one. And then the next one as well, if you take a look at it here, same thing here. So this is going to be 68 for the port, because these are the only ones that did not have an error for them. So destination port 68. All right, so plug that in. So that's the one that's going to be open, because the other two had those error messages, right? Okay, so next one is task number 3, ARP poisoning and man in the middle. ARP poisoning slash spoofing, aka man in the middle attack. ARP is address resolution protocol technology, refers responsible for allowing devices to identify themselves on the network. ARP poisoning is a type of attack that involves network jamming slash manipulation by sending most ARP packets to default gateway. The ultimate aim is to manipulate the IP to MAC address table and sniff the traffic of the target host. Okay, it says there are a variety of tools available to conduct ARP attacks. However, the mindset of the attack is static, so it's easy to detect such an attack by knowing the ARP protocol workflow in Wireshark skills. ARP analysis, in a nutshell, works on the local network, enables the communication between MAC addresses, not a secure protocol, not a routable protocol. It doesn't have an authentication function. Common patterns in request and response announcement and gratuitous packets. Before investigating the traffic, let's review some of the legitimate and suspicious ARP packets. The legitimate requests are similar to the shown picture. A broadcast request that asks for if any of the available hosts use an IP address, and a reply from the host that uses that particular IP address. So we can see that here. And once again, here's how to find that particular information in Wireshark. So global search, just type in ARP. And then from there, you can have other filters to filter out specific criteria. So ARP options for grabbing the low-hanging fruits. We have ARP code 1, ARP request, 2, ARP responses, hunt. They have ARP scanning, possible ARP poisoning detection, and then ARP flooding from detection. So pretty neat here. And if we want to take a look at one of them here, let's just grab this. We'll probably have to fire up another PCAP, I'm sure, right? So let's see here, file, open, and I'm not sure which one we'll be using here, but let's just keep this one. Maybe we'll see something in here real quick. Let's just type in ARP, see if there's anything here. Nothing. Okay, so we'll probably revisit that later on in this task. But here's a picture of what they're talking about here. So the ARP request. There's more information down here. ARP reply. Okay. Says a suspicious situation means having two different ARP responses, a conflict for a particular IP address. In that case, Wireshark's expert info tab warns the analyst. However, it only shows the second occurrence of the duplicate value to highlight the conflict. Therefore, identifying the malicious packet from the legitimate one is in the analyst challenge. A possible IP spoofing case is shown in the picture below. You can see down here that it's saying the duplicate IP address detected for yada yada yada. It says here, knowing the network architecture and inspecting the network traffic for a specific time frame can help detect the anomaly. As an analyst, you should take notes of your findings before going further. This will help you be organized and make it easier to correlate the further findings. Look at the given picture. There's a conflict. The MAC address that ends with B4 crafted in our request with the 1.25 IP address, then claim to have the 1.1 IP address, as we saw earlier when we looked at this, right? Okay. Some notes, detection notes, and findings. Possible IP address match. One IP address announced from a MAC address and has that information up here. Possible ARP spoofing attempt. Possible ARP flooding attempt. So as you're going through and trying to analyze this suspicious activity, you're just going to basically take notes and just have them separated like this, right, to make it easier to investigate things. Let's keep inspecting traffic, spot any anomalies. Note that the case is split into multiple capture files to make the investigation easier. Okay. At this point, this is evident that there's an anomaly. Security cannot ignore a flood of ARP requests. This could be malicious activity scan or network problems. There is a network anomaly. The MAC address that ends with B4 crafted multiple ARP requests with the IP 1.25 IP address. Let's focus on the source of this anomaly and extend the taken nodes. So basically just taking what they further investigated here and plug it into those notes here, which is typically what you'll do whenever you're investigating things of this nature. So once again, possible IP address match, ARP, possible ARP spoofing attempt, possible ARP spoofing attempt again. It names that B4 claims to have a different /new IP address, and then ARP flooding attempt. All right. Up to this point, it is evident that MAC address that ends with B4 owns the 1.25 IP address and crafted suspicious ARP requests against a range of IP addresses. It also claimed to have the possible gateway address as well. Let's focus on other protocols and spot the reflection of this anomaly in the following sections of the time frame. there is HTTP traffic and everything looks normal at the IP level, so there is no linked information with our previous findings. Let's add the MAC address as columns in the packet list pane to reveal the communication behind the IP addresses. So this is pretty neat here, getting all kinds of information as we further investigate this. So they added the other pane down there to get these MAC addresses, as you can see there, right? So they only have IPs there, then they added the MAC address pane here. Okay, one more anomaly: the MAC address that ends with B4 is the destination of all HTTP packets. It is evident that there is a minimum attack, which is man-in-the-middle attack, and the attacker is the host with the MAC address that ends with B4. All traffic linked to 1.12 IP addresses is forwarded to that malicious host. Let's summarize the findings before concluding the investigation. So once again, these updated their notes down here. IP to MAC address matches, 3 IP to MAC address matches, and they are here. Attacker, that attacker created noise with the ARP packets, router gateway, and then victim sniffed. Says the attacker sniffed all the traffic of the victim. Detecting these bits and pieces of information in a big capture file is challenging. However, in real life cases, you will not have tailored data ready for investigation. Therefore, you need to have the analyst mindset, knowing or knowledge and tools, skills to filter and detect anomalies. Note, in traffic analysis, there are always alternative solutions available. The solution type and the approach depends on the analyst's knowledge and skill level and the available data sources. Detecting suspicious activities in chunked files is easy and a great way to learn how to focus on the details. Now use the exercise files to put your skills to practice against a single capture file and answer the questions below. So once again, be sure that you're using the ARP exercise.pcapng file. Answer these questions below. Okay, so go ahead and pause the video, do that, and then come back, and then we'll walk through it together. Okay, let's go ahead and take a look at these questions. What is the number of ARP requests crafted by the attacker? And since we're looking for ARP request, as we read earlier, we could use that by this filter here, arp.opcode equals to 1, and then we can pivot off of that information once we have that displayed to our screen here. But after you go through and you review all this information displayed, you can see that this 1.25 IP seems to be one of interest. So once we have that, then we can right click on the IP and then apply it as a filter. So down here in this pane, you'll go and find the sender IP address here, right click it, apply as filter selected. Okay. And that should give us displayed 284 for our answer there. And what is the number of HTTP packets received by the attacker? All right, since we already know we're looking for HTTP, right, and we know what the attacker IP is, we'll have to pivot off the MAC address identified here. So you can see that down here, this B4 right there, and you can also see it up here too for Ethernet. So we'll have to pivot off that information. And the filter I used for that is going to be this eth.address equals that, and then using this and then there were no other protocol is going to be HTTP is what we're looking for here. So with that information, we can build out our filter like here. Okay. So there we go for that one. It says displayed 90 down there. And what is the number of sniffed username and password entries? All right, for this one, take a look through the information here. You can see that there's forms and such listed here. So since we know that they're looking for username and password entries, well, if you know anything about web requests and things of that nature, then you know you're going to send like a post request to the web server to whenever you enter your username and password into like a web form or anything like that. So with that information or some Googling, what have you, or just by looking at these packets down here, we can see that this application X yada 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 URL encoded is mentioned there, so you can use that information. And also, since this is HTTP, you can see whatever's in here, so you can see all kinds of stuff in clear text, right? So be aware of that. So anyway, so once you have that information, and you can pivot off of that with another filter, which is going to be the um, string for pass, since we know that we can look at it in clear text. So this is the filter I used. So we already have this Ethernet for the Mac, then HTTP for the protocol we're looking for, and then we're pivoting off of that form information, and then the string we're searching for is pass. Since we've identified the pass can be used inside of here. Once you review these packets here, you'll see that pass is mentioned in here, and I'll show you that here in a moment. Let me get rid of all this stuff here. It's lagging a little bit. Okay, let's see here. All right, let's try this again. Let's grab this. Okay, now we have everything slimmed down to what we need to look at. So as I was saying, since it's HTTP, we know that's unencrypted. So we go ahead and look at the packet information. We can see that pass is in here as a key and a value that we can use, right? So that's the information I pivot off of here, and you can see that there's 6 displayed down here for our answer for that one, for username and password entries. You can go through, you can see various different username and passwords sent out in clear text, which we'll need to take note of here. I believe this is one we needed to find, client 986, right? So that was another question here. So there's the answer to that one. Let's see here. So next one we define this client 354, and a easy way to do this is that you can hit Control F. It'll bring up this little options here. Control V, paste it in there, and then hit find to find that answer. And let me just clear all this out. Hit find. Okay. And we need to find the comment, and right away comment.php. Well, that's a telltale sign that, okay, this is probably where comments are going to be posted, right? And then you can see comment equals nice work, exclamation mark. So there we go there for that one. And then task number 4, identifying hosts, DHCP, NetBIOS, and Kerberos. Okay, so identifying hosts when investigating a compromise or malware infection activity. A security analyst should know how to identify the host on the network apart from the IP to MAC address match. One of the best methods is identifying the host and users on the network to decide the investigation's starting point and list the host and users associated with the malicious activity / traffic. Usually enterprise networks are a predefined pattern to name users and hosts. While this makes knowing and following the inventory easier, it has good and bad sides. The good side is that it will be easy to identify host or user by looking at the name. Bad side is that it will be easy to clone that pattern and live in the enterprise network for adversaries. There are multiple solutions to avoid these kinds of activities, but for a security analyst, it is still essential to have host and user identification skills, protocols that can be used in the and host and user identification. So you have DHCP, NetBIOS, and Kerberos traffic. So DHCP is the technology responsible for managing automatic IP address and required communication parameter assignments. You should know what DHCP is by now if you're looking at this Wireshark video. If you're not, a quick Google search will give you the answer for that one, or information on that and how to search for it in Wireshark. Once again, DHCP or boot P. Some more filtering information here to look for specific criteria. So request, you're going to use this filter, ACK and NAC. Just due to the nature of the protocol, only option 53, request type, has predefined static values. You should filter the packet type first, and then you can filter the rest of the options by applying as column, or use the advanced filters like contains and matches. So remember that. DHCP request, options for grabbing low-hanging fruit. So you have option 12, 50, 51, and 61 here. And use contains and keyword, and then ACK, option 15, option 51. And here's the filter for that over here. We have NAC, option 56, rejection, details, or reason. As the message could be unique according to the case situation, it is suggested to read the message instead of filtering it. Thus, the analyst could create a more reliable hypothesis / result by understanding the event circumstances. And here it is in picture format. So they're just doing a search on DHCP or a filter on DHCP information, pulls it back here for review, and then down here in the pane, you can see some additional information, librarian-PC for the host name. Okay, NetBIOS, and this is what it stands for here. Network Basic Input Output System. It's very old technology, but it's still in use in today's world. A Wireshark filter, NBNS, and here's some additional information on how to filter on that. Queries, and they have query detail contains name, time to live, and IP address details. So they're using this filter. It says contains, and then whatever keyword you want to search on. Okay, so this is what it looks like in the picture format here. A basic search on that specific traffic related to that. And then down here in the lower pane, you can see more information, Xerox. So it looks like some kind of, I don't know, probably a printer or something. Kerberos analysis. Kerberos is the default authentication service for Microsoft Windows domains. It is responsible for authenticating service requests between two or more computers over the untrusted network. The ultimate aim is to prove identity securely. So once again, follow a similar format, global search, you're going to type in Kerberos, right? It'll bring back that information, then you can filter off of different criteria, different types of keywords, stuff of that nature. Okay, some packets could provide hostname information as field. To avoid this confusion, the filter $ value. The values end with $ are host names, and the ones without it are usernames. So be sure to take note of that. It says Kerberos option for grabbing the low-hanging fruits. So you have realm, which is the domain name of the generated ticket, addresses, client IP, and NetBIOS name. Note the addresses information is only available in the request packet, and then here's a filter over here on how to do that particular criteria. Okay, and here it is in the image, what it looks like. Search on Kerberos activity, and then once again you can see more information in this lower pane here. It says detecting systems activities in chunk files, blah blah blah. Okay, we already know that. Now use exercise files, put your skills to the test. Okay, so once again, pause the video and then try to go through this yourself. Come back to the video, and we will continue on. All right, let's take a look at these questions. What is the MAC address of the host Galaxy A30? Now, since we already know the host name, you could probably just pivot off of this information here using a string or something like that, right? So anyway, that's exactly what I did, right? So this was the filter that I used. This DHCP.option.hostname contains A30. I'm sure Galaxy would work the same as well, but let's flip over here. And also remember, you can go to this what was it? I believe, yeah, analyze and then display filter expressions, and you can go and search for DHCP related information here, right? And also, if you start typing it out, it'll pop up things that you can choose here, so that should help you as well. So anyway, this is the one I went with, the A30. So hit enter here. It'll go through and it'll search and find this one. So scroll down and host name. You can see that it's Anthony S Galaxy A30, etc., etc. And we just need to grab that MAC address, which is this here. Okay. And just to show you, if we had gone with Galaxy instead of the last part, you have 3 different options here, but you'll land in the same area. You'll see that the host name down here, and then you'll get the same MAC address. So either or should have worked. How many NetBIOS registration requests does live-aljm workstation have? Since we already know the name of it again, you can use a string. So we're going to do something similar as we did here, okay? And let me grab that filter. NetBIOS name contains that information there. Hit that. Now it'll bring up a bunch of stuff, a bunch of noise here that you have to filter out again. And I had used the hint. I want you to use this flag here, equals to 5, to further slim this down. So that's exactly what I did. So I'm gonna grab the full thing here. Okay. All right, so once that's done, you should be able to get the number of registration requests. So if we go back and have our filter in there now, it'll say displayed 16 at the bottom there. Next one, it says which host requested the IP address of this here. And there's a couple different ways you can go and try to obtain this information. I believe you can use Control F to pull up a string here and try to search off of that information here. So once you go through, you need to find which host. So you're looking for host name probably, right? Or something of that nature. But anyway, so what I did was use this filter here, DHCP option requested IP address. So once again, using this DHCP.option and that requested, and then just plugging in the IP address for that. Now you can, like I said, you can go through and try to use this again. So let's actually try that DHCP find. Okay, there's request. There, scroll down, and let's see here. Okay, not sure if I missed it in there, but I'm just going to use my filter just to show y'all what it looks like. Make it a lot easier. There. So once you go down and scroll through, you should be able to find that particular information here. Galaxy-A12 will be our answer there. So there's different ways you can get to this answer here. But like I said, a lot of this will take trial and error unless you just know which particular filter you should be using. All right, so anyway, let's continue on. Next one, we need to load up this Kerberos.pcap file. So I'm going to go to File, Open, and then load it up here, clear all this out. And let's see, the first question says, what is the IP address of user U5? Enter the address in defanged format. So once again, you can try to just enter U5. Actually, yes, I need to go to this string here. So U5, hit enter, and you can go through and try to sift through this information to try to figure this out here. But as you're going through, you'll see that the CNAME string is mentioned, which brings me to my next filter here, which is going to be this Kerberos.CNAME string contains U5. So this makes it a lot easier to get to. So I'm going to hit cancel and plug it in here, hit enter. Bam, now I have my source IP that comes back with this criteria. So if I scroll down, you'll see CNAME string is U5, and then we need this IP address in defang format. So just grab the IP out of there and defang it. You can just throw it into CyberChef, defang IP address, and it'll give you that defang format like this. What is the host name of the available host in the Kerberos packet? So once again, so we're looking for Kerberos information. You can take all this out and then just try to find it this way. And I'm going to Control F, then try to find that string. Well, we need to find the available host in the packets, right? So let me get rid of this here actually, and then just go back and do this. So once you already have your Kerberos information filtered out here, we know that we are looking for a particular host name. And if we scroll back up here, it says the $. So there's host name. So you can try to use this filter here. And this also mentions CNAME, by the way. See, if you were curious about that. So CNAME and I'm sorry, I lost the train of thought here. But anyway, so you can use $sign here just to sift for that. So it says the values end with the $sign or host name. So we can plug that in here. There we go. We have this XP1 $sign. Should be our answer there. All right. So that's and for that task. Next one is tunneling traffic DNS and ICMP. So they're talking about here traffic tunneling, also known as port forwarding traffic or transferring data resources in a secure method to network segments and zones. It can be used for internet to private networks and private to internet flow direction. Tunneling provides anonymity and traffic security. Therefore, it is highly used by enterprise networks. However, as it gives significant level of data encryption, attackers use tunneling to bypass security parameters. Using the standard and trusted protocols used in everyday traffic like ICMP and DNS, ICMP analysis. ICMP is Internet Control Message Protocol, designed for diagnosing interport network communication. You can use basically like ping, you're pinging something, right? Okay, so since it is a trusted network layer protocol, sometimes it is used for DOS attacks. Adversaries use it in data exfiltration and C2 tunneling activities. ICMP analysis in a nutshell. Says ICMP tunneling attacks are anomalies starting after a malware execution or vulnerability exploitation. As an ICMP packet can transfer an additional data payload, adversaries use this section to exfiltrate data and establish a C2 connection. It could be a TCP, HTTP, or SSH data, etc., etc. A large volume of ICMP traffic or anomalous packet sizes are indicators of ICMP tunneling. Still, adversaries could create custom packets that match the regular ICMP packet size, 64 bytes. So it is still cumbersome to detect these tunneling activities. However, a security analyst should know the normal and abnormal to spot the possible anomaly and escalate for further analysis. So once again, global search, ICMP, just plug that in. And then there's some more filter options here to further slim the traffic down or slim out the noise, right? So packet length, ICMP destination address, and encapsulated protocol signs and an ICMP payload. And this is what it looks like if you were to plug it into Wireshark here. So we're filtering on this particular information here, ICMP protocol. And then, of course, in that pane, we can see some more information down there. DNS analysis, domain name system, designed to translate or convert IP addresses to IP addresses, also known as the phone book of the internet, et cetera, et cetera. Basically, adversaries can use this protocol, abuse this protocol to exfiltrate information, right? Or exfiltrate data, C2 activities. DNS analysis in a nutshell, similar to ICMP tunnels, DNS attacks are anomalies appearing or starting after malware execution or vulnerability exploitation. Adversaries creates or already has a domain address and configures it as a C2 tunnel. Okay, you can read the rest there. That says encoded-commands.malicious.com is an example of that. So they're doing various DNS queries here to exfiltrate data or send commands and such via like a C2 server and whatnot. When this query is routed to the C2 server, the server sends the actual malicious commands to the host. As DNS queries are a natural part of networking activities, packets have the chance of not being detected by network parameters, and you should know how to detect these anomalies basically. So once again, basic search, DNS, and then if you want to further trim out the noise or look for specific criteria, just use other filtering options like DNS contains, DNS cat, and then et cetera, et cetera. So you can search for various different things here. DNS or query length, anomalous and non-regular names, DNS addresses, long DNS addresses with encoded subdomain addresses, known patterns with DNS cat and DNS to TCP, statistical analysis like anomalous volume of DNS requests for a particular target, and then bang MDNS is disable local link device queries. And here's another example of what they are looking for inside of here for that suspicious DNS activity. So once again, pretty straightforward here. We're going to go through some exercises. Once again, make sure you're using this particular PCAP file when you're going through these questions. So pause the video, try to answer these yourself, then come back to the video, and then we will continue on. Investigate the anomalous packets. Which protocol is used in ICMP tunneling? All right, as we read earlier in this room, there's a few different protocols that I had mentioned earlier, right? So it could be TCP, HTTP, or SSH data. Now you have to do some manual digging in this one and try to find that particular information. So in this pane here, it should appear. So once you're going through and sifting through everything, you should, there we go. So we just passed one. You'll see additional information here. You'll see that Diffie-Hellman is mentioned, SSH is mentioned, SSH is mentioned, right? So that should be what we are looking for there. The next one, we need to look at the DNS PCAP file, and then analyze the anomalous packets, and then find the DNS query in question, and then defang that domain that comes up in that particular packet. So once again, we're going to load up that PCAP file, and we're going to use the filters. Now, before in the room, we found this information here. It says these queries are longer than default DNS queries and crafted for subdomain addresses. Unfortunately, these subdomain addresses are not actual addresses. They are encoded commands. So we can try to look for suspicious activity using this filter here, as we learned about in the room earlier. And once again, you have to do some manual work over here. So as you're sifting through all of this information, you'll see some very odd looking ones, right? You'll see that this data exfil.com is mentioned, and you can see it even better on this left pane here, if I can find it. Let's see. There we go, under answers. See how it's very long like that? It looks very suspicious. So that'd be the one we're looking for here, and we just need to grab the domain name. That plug it into a tool like CyberChef to defang it. Okay, so you're going to use defang URL here. Once it's defanged, just copy and then paste it in there. So we're done there. Next one is task number 6, clear text protocol analysis, FTP. Investigating clear text protocol traces sounds easy, but when the time comes to investigate a big network trace for incident analysis and response, the game changes. Proper analysis is more than following the extreme and reading the clear text data. It is important to create statistics and key results from the investigation process. The analyst should have the required network knowledge and tools to accomplish this. Let's simulate a clear text protocol investigation with Wireshark. So first one up is FTP, which is File Transfer Protocol. And it says it focuses on simplicity instead of security. As a result, secured environments could create security issues like man-in-the-middle attacks, credential stealing, phishing, malware planting, and data exfiltration. Some notes to take note of here is Wireshark filter. Once again, a basic search, FTP, and then some more filters down here. So some options for low-hanging fruit here. The X1X series information requests, X2X series connection messages, and X3X series authentication messages. And an example would be 200 means command successful. And here's some other examples down here below. So looking for these two codes here, these X1X addresses or series options for grabbing low-hanging fruit. So 211 system status, 212 directory status, 213 flag status, and this is how you filter on that. So they're filtering on this FTP response code, as you can see, and then they're just plugging it in. All right, so make sure to take note of that information. There's a lot here to take in. Filters for FTP alone, and here's some additional ones here for grabbing like username, password, current working directory list, things of that nature. Advanced usages, examples for grabbing low-hanging fruits, brute force signal, list field login attempts, brute force signal, list target username, password spray signal, list targets for a static password, and here's the filter criteria for those. So a lot of things you can filter on with FTP, and here's an example of just regular FTP, and then you can just build your query out, build your filter out via this information here, and using those filters as discussed in these tables. Okay, so once again, we're going to take a look at some PCAP files and then answer these questions. So pause the video, go ahead and do that, and then come back once you're done or get stuck, and we will continue on. How many incorrect login attempts are there? Now for this one, we can search on this particular response code 530, and that will give us our answer there. So as we learned earlier, so display 373 is going to be answered there. But as we learned earlier about some response codes we can search on here, right? So no login, invalid password can give us the answer for that one. Next one says, what is the size of the file accessed by the FTP account? Okay, and for that one, you can use this 213 code to search on. So let's go ahead and delete all this out of here. Search on that, and then you can see the response arg is going to give us that size information here. So it's 39,424 should be what we're looking for there. Next one says the adversary uploaded a document to the FTP server. What's the file name? Since we already know it's a document, right? So it's probably gonna be like a .doc or .x for the file extension. And right away we see something here and it says resume.doc. So that's probably what we're looking for. So what you can do is right click it and then follow and then TCP stream, and voila, it brings up a lot of information. This is what I would typically do if I was to do this in the real world, and this was clear text protocol I was looking at. I would right click it and then follow the stream to figure out what's inside that packet that I can see. All right, so anyway, so the file name is going to be resume.doc. That's the one they're referencing here, right? So that should be our answer there. The next one says the adversary tried to assign special flags to change the execution permissions of the uploaded file. What is the command used by the adversary? So once again, as you're going through this stream here, you can scroll to the bottom here. You can see chmod 777 resume.doc is what they did here, and they got a permission denied. Some other things of interest to take note of here. You can see the FTP server they're using. The software they're using for this is Pro FTP. And then it says that it's an anonymous server, right? So they're using anonymous logon, which is highly not advised to use for obvious reasons. But anyway, so it's just some things there to take note of. Anyway, so task number 7, clear text protocol HTTP. Oh, by the way, speaking of the DNS stuff we learned about earlier, here's an article here. I'll put the link in the description that you can take a look at here, talking about how threat actors are using DNS to do malicious activities. But anyway, so let's flip back over here. HTTP analysis. You know what HTTP stands for by now. This is the standard type of network activity to request / serve web pages. Is not blocked by default, yada yada yada. So basically, threat actors can use HTTP to do malicious things with, right? So phishing pages, web attacks, data exfiltration, C2 activity, HTTP analysis in a nutshell. Once again, basic filters, HTTP or HTTP2 for that particular protocol. So you're talking about request methods here. So you have get, post, and there's others out there as well. But most of the time, you probably just see these get and post requests. So you're going to, if you want to get using a get request, you're receiving something from the web server itself to display to the web browser. Then post, you're posting something to the web server like username, password, credentials, or whatever, right? And then HTTP.request to list all requests. Let's see here. Different status codes you can look at: 200 OK, 301 move permanently, 302 move temporarily, and you can see the rest there. So once again, you can filter off that criteria using http.response.code and then equals whatever response code you're particularly interested in finding. HTTP parameters says you can look at user agents, request URI, full URI. URI stands for Uniform Resource Identifier, and this is what it looks like over here. So user agent nmap, Firefox, whatever they have in there. And this can be spoofed, by the way. They can put whatever they want for these particular user agents, so just be cautious of that, or be aware of that. URI contains admin, full URI contains admin, etc., etc. HTTP parameters. So you can look at particular things like server name, host name, connection, line-based text data, HTML form, URL encoded information. We kind of saw some of this earlier, I believe, as we were looking at one of the other tasks, right? User agent analysis. As adversaries use sophisticated techniques to accomplish attacks, they try to leave traces similar to natural traffic through the known and trusted protocols. For an analyst, it is important to spot the anomalous signs on the bits and pieces, yada yada yada. User agent is one of the great resources for spotting anomalous in HTTP traffic. In some cases, adversaries successfully modify the user agent, as I was explaining earlier, right? So they can put whatever they want. I mean, you can use tools like Burp Suite and put whatever user agent you want in there to send those requests out, right? So that's why it says you cannot rely only on the user agent field to spot anomalies. Never whitelist the user agent. User agent based anomalies / detection hunting and is an additional data source to check, etc., etc. If you're unsure about the value, you can conduct a web search to validate your findings with the default and normal user agent info example site. Okay, that's good to know there. And then if you want to search on user agent, you can use this filter here. All right, and then here's some other details here that you can further investigate those user agents. So there's probably some quick wins here we can use as we're going through this particular task. And here's examples of what it looks like. So just looking for all these user agents, right? And they have it listed up here in a column to make it easy for you to find. And then it breaks it down even further in those panes, of course. So they're using wfuzz, which is a tool out there you can use for fuzzing, directory brute forcing, stuff like that. Log4j analysis. This is a well-known vulnerability that exists out there in the environment. You can just do some Googling on that. But if you want to search on that particular area, this is what you can do here. It says research outcomes for grabbing low-hanging fruits. The attack starts with a post request. There are known clear text patterns such as this here. That's why you go out there and read blogs and such. They can give you some additional details that you can use in your investigation, right? So that's basically what they're using. They're using OSINT information and they're applying it to this particular tool, which happens to be Wireshark, right? But you can apply that to any other tool out there. So anyway, so here's Wireshark filters you can use to search for this particular vulnerability, right? If they're trying to exploit it and whatnot. And this is what it looks like in real time image here. So you can see all kinds of funky information there. User agent string stuff here. Okay. So once again, we're going to analyze these PCAP files and answer these questions. So go ahead and do that. Pause the video and then come back, and then we'll walk through it together. Let's take a look at these questions. Investigate the user agents. What is the number of anomalous user agent types? Now remember, to get a list of user agents, what you can do is just use this initial filter here. Okay, so once you have that done, you can go through some of these packets here and try to identify the user agent field here. So once you have that identified, right click it and then apply as a column. So you have everything listed here. Now basically you just go through here and just filter out the ones that are, suspicious looking. Okay, so you're gonna see various different ones in here like WFuzz, SQL Map, a lot of no-brainers in here. And as you're going through and identifying those suspicious user agents, you'll come across that there are 6 of them in here. And then I had to use the hint to find this last one here, this Windows NT 6.4, and this is not a real Windows system. So take that into consideration. But here are all the 6 user agents of interest here that you need to find. There's another one in here, another question here that says, what is the packet number with the subtle spelling difference in the user agent field? That's going to be packet 52 as you're sifting through here. Okay, so you're going to do this in the real world. You're going to have to sift through various different packets looking for suspicious activity, even if it's something as minor as a spelling issue here. So if you go in here and we find that particular packet, which was packet 52 here, you can see that it says Mozilla instead of Mozilla. It says Mozilla, so that's the answer for that one. And the next one is we need to take a look at this HTTP PCAP file, log4j information that we're looking for here. So remember, log4j that we saw above from doing like OSINT research or whatever, right? So you're going to take that specific criteria to try to find. So for this one, we're going to look for this IP contains JNDI or exploit. So let's go ahead and do that. Let's load up that particular PCAP file. Okay. So it's loaded up here. Use our filter. All right. Off the bat, we can see there's some funky stuff going on here in this user agent field, and the packet number is going to be 444 for that one. And it says the starting phase from our notes is going to be a post request. So it says the attack starts with a post request. So that's additional information that you can take into consideration there. And you can see that it says post there. So there you go for that one. And then the next one, it says that we need to find attacking starting phase and decode the base64 command. What's the IP address that's in there? So let's go ahead and do that. So we know that our information is in here, and you can see base64 encoded information right there. So I'm going to see if we can just copy this out of here, and if it doesn't let us copy that way, we can look over here and get it from here. So we can also see the post request there. So we'll drop that down, and user agent field is what we need. So it's going to be a long string in here, right? So we'll just copy this value right there, and then go over to the cyber chef and want to from base 64. So we want to decode this. So let's get this out of there. Paste that in there, and then right off the bat we can see some interesting data. So let's get rid of this other stuff we don't need in there. We'll just delete everything before this /, make it easier to see. But yeah, we can see that this wget, and they're pulling it from this IP address here, and they're pulling this particular file. And while it's downloading, it's going to fire off this chmod to make an executable lh.sh, right? And then it's going to fire off that particular script. Okay, so there's our answer there. And now we need to defang it, and you can double this up. So defang IP address. There we go. So we just need to grab this particular IP address in question for that answer there. So we are done with that one. Next one is task 8, encrypted protocol analysis, decrypting HTTPS. All right, so basically this is just explaining what HTTPS is, what it does. HTTPS uses TLS protocol to encrypt communication, so it's impossible to decrypt traffic and view the transmit data without having the encryption/decryption key pairs. The packet will appear in different colors as the HTTP traffic is encrypted. Also, nothing will be visible in it because it's encrypted, obviously, right? All right, so here's some filter information here. So if you want to filter on that particular criteria, HTTP.request, you have TLS in here, handshake type equals 1, 2, SSDP. All right, so interesting information there. And here, this is what it looks like in real time. If you were to look up this particular traffic inside of Wireshark, you can see the color difference is different. When it's green, that means it's in like clear text and encrypted format, so you can probably read what's in those packets, right? Whereas if it's encrypted, it's going to be a different color, and you won't be able to see what's inside that packet. Okay. Similar to TCP three-way handshake process, TLS protocol has its handshake process. First two steps contain client hello, serve hello messages. The given filters show the initial hello packets in a captured file. These filters are helpful to spot which IP addresses are involved in TLS handshake. And if you want to search for client hello, you'll use this filter here. And then server hello, you're going to use this filter here. Okay. And also, if these columns aren't there, you can always add those columns like we had showed in the previous task, okay? And additional information in the lower panes, all right? It's just basically showing what I just explained above. This is how you add the key in order to decrypt it. So the encryption key log file is a text file that contains unique key pairs to decrypt encrypted traffic. These key pairs are automatically created per session when a connection is established with a SSL TLS enabled web page. So to do this, we need to set up an environment variable and create the SSL keylog file, and the browser will dump the keys to this file as you browse the web. SSL TLS key pairs are created per session at the connection time, so it's important to dump the keys during the traffic capture. Otherwise, it is not possible to create or generate a suitable keylog file to decrypt the traffic. You can use the right-click, edit, preferences, protocol TLS menu to add or remove keylog files, and this is showing you what it looks like here. All right, interesting. Adding it via here, preferences, protocols, and then TLS, and then browsing to that log file. Viewing traffic without the keylog files, without the keylog, and then with the keylog, you can see there's a lot more information there, right? And you can see what's inside there. It says the above image shows that the traffic details are visible after using the keylog file. Note that the packet details and bytes pane provides the data in different formats for investigation. Decompressed header info and HTTP packet details are available after decrypting the traffic. Depending on the packet details, you can also have the following data formats. You have frame, decrypted TLS, decompressed header, reassembled TCP, and reassembled SSL. Again, we're going to take a look at these PCAP files and answer these questions. So go ahead and do that. Pause the video and then come back to the video and we'll continue on. What is the frame number of the client hello message sent to accounts.google.com? Now let's flip back over to our VM here, and remember we can use this filter to find that particular information. We were filtering on this client hello, so once you have that in, hit enter. Now take a look at one of these here. Inside of one of these drop downs, we can dig into we can add a column for the server, if I can remember where it was located in here. Maybe I think it was under here, under TLS, transfer layer security. Okay, then extension. You want to go to the server name. I believe it's this one. Yes, and then it's for server name. Right click it, and then you want to add this as a column. Make it easier to look at, right? Accounts.google.com is the one we're looking for. So 16 is going to be our number there for the frame. Next one says decrypt the traffic with the keylog file.txt file. What is the number of HTTP to packets? So first things first, let's go ahead and load that up. So I believe it was an edit, then preferences, and then it was those protocols, and then we need to go find that particular protocol. So let's see here. HTTP2. No, okay, I'm in the wrong area. It was under, let's see, I forgot where it was. Preferences, protocols, TLS, that's where I'm looking for. So TLS, all the way down here, there. Then we need to browse. Then inside that same folder is the keylogs file. Open. Okay. Okay, so now that should be decrypted, and I believe we just do HTTP2 search on that information, right? So now that the information is decrypted, over to frame 322. So let's go ahead and do that. All right, so 322, there it is. Okay, and then we need to find the what's the authority header into the address. Okay, then you'll need to drop down this hypertext transfer protocol 2, and then it will need to look for the authority header here, which is going to be this here. So safebrowsing.googleapis.com, and remember to put it into Defang format. You can do that with Cyberchef or a different tool. Anyway, so the last one here says investigate the decrypted packets and find the flag. What is the flag? All right, and also there's a hint over here if you need help with that. Okay, so first thing, we need to find a file that has that information in it. So what you can do, since we already know we're looking for a flag file, you can probably just search on that. So hit Control F, bring this up, and let's try this flag. Okay, nothing there. Let's try flag.txt. Okay, there's something here. All right, so we can do is right click on this. And actually, we can go to File, and then we can export objects and HTTP. There we go. Okay, so once we have that, it should be this first one here. Let's save this. Sure, let's just save it in here. Save. And let's see if we can locate it. See desktop. Exercises, then HTTPS. There we go. There's the flag. So that takes care of that one. All right. Now, I'm assuming they wanted us to sift through all of these decrypted packets here, which would take some time, but you could just do flag.txt if you know what the file name is or some inkling of what it is. If not, then of course you'll have to search through these decrypted packets and try to find something of interest, right? Post in the comments if you found an easier way to find that one, but that's what I did to find it, as you saw there. Task number 9, bonus. Hunt clear text credentials. Up to here, we discussed how to inspect the packets for specific conditions and spot anomalies. As mentioned in the first room, Wireshark is not an IDS, but it provides suggestions for some use cases under the expert info. However, sometimes anomalies replicate the legitimate traffic, so the detection becomes harder. For example, in a clear text credential hunting case, it is not easy to spot the multiple credential inputs and decide if a brute force attack or if it's a standard user that mistyped their credentials. As everything is presented at the packet level, it is hard to spot the multiple username and password entries at once. At first glance, the detection time will decrease when an analyst can view the credential entries as a list, Wireshark has such a feature to help analysts who want to hunt clear text credential entries. Some Wireshark dissections or dissectors, FTP, HTTP, IMAP, etc., are programmed to extract clear text passwords from the captured file. You can view detected credentials using the Tools Credentials menu. This feature works only after specific versions of Wireshark, version 3.1 later. Okay, it says since this feature works only with particular protocols, it is suggested to have manual checks and not entirely rely on this feature to decide if there is a clear text credential in the traffic. Once you use this feature, it will open a new window and provide detected credentials. It will show the packet number, protocol, etc. This window is clickable. Clicking on the packet number will select the packet containing the password, and clicking on the username will select the packet containing the username info. The additional part prompts the packet number that contains the username. All right, that's pretty neat there. I didn't even know about this feature in Wireshark. It works for specific protocols. But anyway, so this seems like maybe some quick wins we could do real quick. So let's just take a look at these questions. So we're going to look at these bonus exercise PCAP file. What is the PCAP number or packet number of the credentials using HTTP basic auth? And then we need to find one where empty password was submitted. So go ahead and pause the video, try to answer those yourself, then come back and we'll continue on. All right, let's go ahead and dive over into Wireshark here. And it said that we need to go to the tools section and then credentials, and then we have something listed out here. So as you're sifting through here, um, you'll come across the HTTP basic auth, and there's only one entry in there that has that, right? So HTTP, click on that, and this appears to be what we are looking for. So you can also, it also takes you down to that particular packet, right? So you can see the credentials and other information inside of here in clear text. So that takes care of that one. And then the next one, it says that we need to find packet number where empty password was submitted. So basically, I have to cycle through all these here to find that one. But once you've done that, you'll see that packet number 170 is the one we are looking for here. Okay, and then if you want to take a look there, since it's FTP, you can follow it. So you can right click it and then follow TCP stream. And you can see that username is administrator. The passwords, there's nothing there for the passwords blank. So that's our answer there for that one. And the next one is another bonus actionable results. Since you have investigated the traffic, detected anomalies, created notes for further investigation. What's next? In every case, investigation is carried out by a crowd team. As a security analyst, there will be some cases you need to spot the anomaly, identify the source, and take action. Wireshark is not all about packet details. It can help you create firewall rules ready to implement with a couple of clicks. You can create firewall rules by using tools, then firewall ACL rules menu. Once you use this feature, it will open a new menu or new window and provide a combination of rules, so IP port and MAC address base, for different purposes. Note that these rules are generated for implementation on an outside firewall interface. Currently, Wireshark can create rules with the following: so net filter, IP tables, Cisco iOS, standard extended, IP filter, etc., etc. Okay, this is what it looks like here when you click tools, firewall ACL rules. It generates them out for you, and you can, looks like you can easily copy them out. So that's pretty nifty. I didn't even know about this feature. All right, so question time. Be sure to pause the video and try to answer the question yourself, then come back to the video and we will continue on. Okay, so let's take a look here. It says select packet number 99, create a rule for IP firewall. What is the rule for denying source IPv4 address? And let's take a look at this hint real quick. Oh, okay, we already know that, so let's clear all this stuff out. Tools, firewall ACL. When you go to set packet 99, right? Yeah. So we'll scroll all the way up here and find it. There it is. Once you've found packet 99, just make sure to click on it to highlight it. And then we're going to go to tools, firewall ACL rules, and then make sure to change this to the correct one, which is going to be this IP firewall, I believe is what it said. Yeah, IP firewall. So make sure it's that one, and then we need to make sure that it's denying source IPv4 address, which should be this one here, at deny IP from, etc., 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 to NEN. Okay, next one, packet 231. Once again, IP firewall, and then allowing destination MAC. So let's go back over here and yeah, 231. So let's locate that packet. Okay, highlight it, tools, and then switch this to the correct one. Okay, and then the MAC address should be one of these here, which says allowing destination MAC address. We need to put an allow rule in here, right? So let's see here. Okay, so basically you're just going to uncheck mark that deny, and it's inbound still, right? So it should be here at MAC address or MAC destination address you're allowing in. So add allow the MAC. So this should be what we're looking for here. Yep. Okay. And then there's also hints here if you get stuck. So it even says that deny option can help. So deselect that one.
Once again, here is an additional website here called malwaretrafficanalysis.net, where you can go and practice your hands-on keyboard experience with Wireshark. Alright, there's various different files containing PCAP captures that were found out in the wild that you can go and practice your skills with. Right, as you can see that it's explained here, and also you can just go to traffic analysis exercises. So click here, it says for training exercises to analyze PCAP files of network traffic, and you can see all kinds of different files to play around with. If we go back one, we can see another one that says for some tutorials and workshop material that will help for these exercises, so you can go and check out that one as well if you're interested.
And let's wrap this up for task number 11. We went through quite a bit in this room here. All right, so in this room, we covered how to use Wireshark to detect anomalies and investigate events of interest. At the pack level, now we invite you to complete the Wireshark challenge rooms, Carnage, Warzone 1, and Warzone 2. So check those out if you want to improve your skill set. Wireshark is a good tool for starting a network security investigation. However, it's not enough to stop threats. You should know about IDS, IPS, and some other tools out there, and also have the investigative mindset. And let's see, the following rooms will help you step forward in your network traffic analysis, anomaly / threat detection, NetworkMiner. We have a bunch of snort rooms here, Zeek, and then Brim, which I should have videos over all of these. So check out my channel if you're interested there, and then take notes as needed. We went through quite a bit here. This was a very lengthy room, so hopefully y'all took notes. And there's quite a few things in here that I didn't even know about how to use, like just that tool section we just went over, that those tool options, right? Um, but yeah, Wireshark is a very versatile tool that you can use in your career for whatever task at hand when it comes to network traffic analysis. So anyway, if you enjoyed the video, if you found it valuable, be sure to hit that like button, subscribe to the channel with the notification bell if you're new here, comment on the video, which part of the room did you enjoy the most, which part did you struggle in, all that good stuff. As always, thank you for taking the time to watch my video. Have a nice day, and I will see you later. Hey everybody, this is WireDogSec. Just a quick reminder to subscribe to the channel and hit the notification bell. Once you hit the notification bell, be sure to set to all notifications so you know every time I post to the channel, upload a video, all that good stuff. Let's continue to grow our glorious community here. We are in the cyber trenches. We're not just reporting on it. Be sure to check out my channel as well. I have tons of videos that you can see here, over 300 videos ready for you to check out and learn something from. Be sure to review my posts. I'm frequently posting new things to my channel here, including jobs and everything related to that. Also, I have tons of playlists here that you can review, make it more convenient for you. Anyway, happy defending, happy hacking, enjoy the video. Hey everybody, welcome back to my channel. This is WireDogSec. Back with another video for you guys. Today's video, we are in TryHackMe, SOC Level 1. This is the Network Security and Traffic Analysis module, and this is the NetworkMiner room. Learn how to use NetworkMiner to analyze recorded traffic files and practice network forensics activities. Now, there's a lot of reading in this room, so we're going to skim through some of it here, but be sure to navigate to this particular room. I'll have the link in the description as usual, and read through all of it in great detail, please, so that you understand the full capabilities of this tool. Now, before we get into it, be sure to like, comment, and subscribe to the channel if you are new here. With that notification bell, make sure to set that to all notifications so you know when I post to the channel, upload a new video to the channel, all that good stuff. Now let's go ahead and jump into it. All right, this is task number 1. It says NetworkMiner is an open source traffic sniffer, PCAP handler, and protocol analyzer developed and still maintained by WireDogSec. There's the official description right here. NetworkMiner is an open source network forensic analysis tool, in fact, for Windows, but also works on Linux, Mac, FreeBSD. It says can be used for passive network sniffer / packet capturing tool to detect operating system sessions, all kinds of stuff. You can see the rest there. NetworkMiner has the first release back in 2007, become a popular tool among incident response teams and law enforcement. For this room, you will be expected to have basic Linux familiarity and network fundamentals, ports, protocols, and traffic data. If you've been following my channel, you should already have this information in your head already. We suggest completing the network fundamentals room, or you can check out my channel for a video related to that if it's there. Before working in this room aims to provide a general network forensics overview and work with NetworkMiner to investigate capture traffic here. And this tells you how to use this room here. I already activated the VM, as you can see here in split screen. All right, so we've already done this here, and it says that we need to access the information via this particular folder here. I guess any of these folders we'll be working out of. So already done. Read through everything here. Task number 2 here is going to talk about NetworkMiner and forensics. Hey everybody, this is WireDogSec. Just a quick reminder to subscribe to the channel and hit the notification bell. Once you hit the notification bell, be sure to set to all notifications so you know every time I post to the channel, upload a video, all that good stuff. Let's continue to grow our glorious community here. We are in the cyber trenches. We're not just reporting on it. Be sure to check out my channel as well. I have tons of videos that you can see here, over 300 videos ready for you to check out and learn something from. Be sure to review my posts. I'm frequently posting new things to my channel here, including jobs and everything related to that. Also, I have tons of playlists here that you can review, make it more convenient for you. Anyway, happy defending, happy hacking, enjoy the video. Okay, and you can see the XE there. NetworkMiner forensics, the ultimate goal of network forensics is to provide sufficient information to detect malicious activities, security breaches, and network anomalies based on network traffic, and NetworkMiner is a great tool to help as it provides quick and useful hints on where to start from, specifically context of captured hosts like their IP, MAC, host names, and OS information, list of potential attack indicators, tools or toolkits used to perform the potential attacks like Nmap. Makes sense if it's capturing and looking at PCAP data, right? So that information should be located in PCAP information, right? PCAP or didn't happen, isn't that what they say? Supported data types. So we have live traffic captures, and log files. Okay, NetworkMiner is capable of processing, handling both packet captures, which is PCAP for short, and live traffic. Therefore, we can focus on live and capture traffic in this room. So later on, it's going to compare this with Wireshark. I know Wireshark's a well-known tool out there as well that can do analysis of PCAP files, and it can also do live traffic analysis because you can sniff one of your interfaces, right? So task number 3 here, what is NetworkMiner? NetworkMiner in a nutshell, so we have capability and description here. Traffic sniffing, it can intercept the traffic, sniff it, and collect and log packets that pass through the network. Parsing PCAP files, protocol analysis, OS fingerprinting, file extraction, credential grabbing, clear text keyword parsing. So you can see that it can do a plethora of things here. It has a lot of capabilities that you can utilize to assist you in your incident response or digital forensics endeavors. So we are using NetworkMiner free edition in this room, but a professional edition has much more features as usual. You can see the differences between free and professional versions here. So check that out if you're interested in learning about the professional version compared to the free version, which we're going to use here in a second. So operating modes here, 2 main modes. You got sniffer mode. Although it has a sniffing feature, it is not intended to use as a sniffer. The sniffer feature is available only on Windows. However, the rest of the features are available in Windows and Linux OS. So based on experience, the sniffing feature is not as reliable as other features. Therefore, which is just not using this tool as a primary sniffer, etc., etc. You can see the rest there. Packet parsing / processing. NetworkMiner can parse traffic captures to have a quick overview and information on the investigated capture. This mode is mainly suggested to grab the low-hanging fruit before diving into a deeper investigation. So I'm assuming that maybe you can use this tool in conjunction with maybe a tool like Wireshark for more in-depth analysis, or maybe you can even go even further with NetworkMiner. Like I don't think I've ever used NetworkMiner before. I think I've heard of it, but never used it in the real world. Pros and cons here. Okay, so pros: OS fingerprinting, easy file extraction, credential grabbing, clear text keyword parsing, overall overview. Cons: not useful in active sniffing, which we already found out about that when we read about it earlier. Not useful for large PCAP investigation. Limited filtering, not built for manual traffic investigation. And here we go. Here, differences between Wireshark and NetworkMiner. NetworkMiner and Wireshark have similar base features, but they separate in use purpose. Although main functions are identical, some of the features are more stronger for specific use cases. The best practice is to record the traffic for offline analysis, quickly overview the PCAP with NetworkMiner, and then go deeper with Wireshark for further investigation. Now, didn't I say that earlier, right? You can use this in conjunction with Wireshark. So if you want to get that overall or that first look at it, that first triage to say of that PCAP information, go ahead and use NetworkMiner. You see something that needs to be further investigated, then you can switch over to Wireshark for more deeper analysis and investigation. And it breaks it down here in this fancy little table here. You have featured NetworkMiner and Wireshark. Purpose, quick overview, traffic mapping, and data extraction for NetworkMiner. And then for Wireshark, in-depth analysis here. So GUI, sniffing, handling PCAPs, OS fingerprinting, parameter, keyword discovery, et cetera, et cetera. It can do all kinds of stuff here. Like it says, it depends on the use case that you're going to be using it for, right? So you can see here and take a look at the capabilities, compare and contrast these two different tools here, but maybe you'll be using two of them or both of them in the real world. Task number 4 here, so tool overview number 1. So let's see what they're cooking with here. Landing page. This is landing page of NetworkMiner. Once you open the application, the screen loads up. So let's go ahead and fire this bad boy up and see what it looks like here so we can try to follow along. Okay, while that's loading up, we'll see here. File menu, self-explanatory as with usual tools. So if you go to file menu here, you have open the files, receive PCAP over IP, exit. Okay. It says file menu helps you load PCAP files or receive PCAP over IP. You can also drag and drop PCAP files as well. That's neat. NetworkMiner also can receive PCAPs over IP. This room suggests using NetworkMiner as an initial investigation tool for low-hanging fruit, et cetera, which we already know about that. Tools menu here, so we're just following along here. Clear GUI, delete capture data. The tools menu helps you clear the dashboard and remove the capture data. Help menu provides information on updates in the current version here. So there we go. Check for updates about NetworkMiner. Case panel. The case panel shows the list of investigated PCAP files. You can reload / refresh. View metadata details and remove loaded files from this panel. Viewing metadata of loaded files. That's pretty neat and pretty nifty here, right? So we can load it over here in this case panel side. So I think that will come in handy here as we go through these exercises later on. And this is what it looks like when you actually have something loaded in here, apparently. So yeah, it looks pretty straightforward here. File, start, in, et cetera, all kinds of metadata information you can examine. Host. The host menu shows the identified host in the PCAP file. This section provides information on IP address, MAC address, OS type, open ports, sent, received packets, incoming, outgoing sessions, host details. OS fingerprinting uses the Satori GitHub repo and POF, and the MAC address database uses the MAC ages GitHub repo. You can sort the identified host by using the sort menu. You can change the color of the host as well. Some of the features OSINT lookup are available only in premium mode. The right-click menu also helps you copy the selected value. The free version can offer a plethora of capabilities that you can use at your disposal, right? And then for anything else that's paid for, you can probably use an alternative tool to use, right? I mean, there's for a lot of paid tools out there. There's oftentimes an open source or free alternative tool to that. So just for your information here, but yeah, so we're gonna look at something like this whenever we get down to it. And you can see here, looks similar to what you'd probably seen like Wireshark, right? If you ever use Wireshark like that, but this is in a fancy little infographic. Looks like it's a little bit easier to read. Let's see here, sessions. The session menu shows detected sessions in the PCAP file. The section provides information on the following: frame number, client and server address, sort and destination port, protocol, start time. So it looks something like this here. Okay, pretty straightforward. You can search for keywords inside frames with the help of the filtering bar. It's possible to filter specific columns of the session menu as well. This menu accepts 4 types of inputs: extract phase, all words, any word, and regex. Or regexe, whatever how that's pronounced. DNS menu shows DNS queries with details. This section provides information on the following: so frame number, timestamp, client, and server, and you can see the rest here. All kinds of information regarding DNS. So some of the values, Alexa top 1 million, are available only in premium mode. The search bar is available as well, so it looks something like this when you fire it up and start using these fancy features here. And next one is credentials. It says the credentials menu shows extracted credentials and password hashes from investigated PCAPs. You can use Hashcat, awesome, and John the Ripper to decrypt extracted credentials. NetworkMiner can extract credentials using or including Kerberos, NTLM, RDP, HTTP, etc., all kinds of credentials that it can extract, right? The right click menu is helpful in this part. You can easily copy the username and password values. So it looks something like this, okay? Pretty neat there. Answer the questions here. So once again, pause the video, go through and try to answer these questions yourself. Then come back to the video and we will walk through them together. All right, how did y'all do? Hopefully you're able to find the answers yourself. If not, let's go ahead and step through this process together. First one up says use mx-3.pcap file and answer these questions. What is the number, a total number of frames? So first off, let's go to our files here, and then we're going to open up that pcap file. So be sure you're in this exercise files folder here. So here's the first pcap we need to analyze. So that's loading up here. And we need to find the total number of frames. In order to do that, here on the right side where it says case panel, we're going to go ahead and double click this, I believe, or we can just right click it and then, yeah, show metadata. All right, make this a little bit bigger. And you can see here we have file name, start, end, and we have frames here, and a bunch of other stuff. So here's the frames here, 460, located in the metadata. So we're done with that one. Next one says, how many IP addresses use the same MAC address as the host, the .203, okay? So let's go ahead and take a look here. Host tab as so. We need to find out how many hosts use the same MAC address. So first off, let's locate it. And here's the .203. So we're going to hit this drop down menu here. And then as we're analyzing this information like so, we can go ahead and take a look at the MAC area here. Hit another drop down here. And we can see that there's 2 hosts listed in here. It's the same MAC address, same MAC address. So both of these hosts here, this .223 and this .99 are what we're looking for here. So 2 is going to be the answer there. The next one says, how many packets were sent from host 65.208.228.223? So once again, you can go ahead and play around with this drop down here. I went ahead and went to sent packets, right? And we're going to locate this .223, which is this one here. So with that drop down, and then we need to see how many packets were sent. So, and we can see that here, sent packets, right? 72 packets were sent. So that's going to be our answer right there, 72. Next one, what is the name of the web server banner under the .223? So once again, we're going to take a look at this drop down here and find that information. This should be under host details, if I'm not mistaken. There we go, web server banner. And we see the Apache appears to be the web server. All right, next one, we're going to take a look at this mx-4.pcat file. So we can go ahead and get rid of this. We don't need it anymore. So we're going to remove that out of here. Now we're going to go back to the same directory. And this time I'm going to open up this pcap here for. All right, so we have 2 things listed here. And it says that we need to find the extracted username. So to do that, we're going to need to go over to credentials here, right? And then analyzing this information, we have client server protocol username and password. So these are the 2 locations where we need to find the information here. So username here is going to be this this b/administrator. Okay, so you're just going to go ahead and right click and copy that. Next one says what's the password here. Now it's not going to be this one. It's going to be this one down here, this long one here. That's what you're going to need to get out of there. That's the password that's extracted. Okay, so right click it and then copy password and paste it in there. That's done for that particular section. Task number 5 here, tool overview number 2 here. So let's go ahead and take a look and see what they're cooking with. Files. The file menu shows extracted files from investigated PCAPs. This section provides information on the following: frame number, file name, extension, size, etc., etc. You can see the rest there. Some features, OS or OSINT hash lookup and sample submission are only available in premium mode. The search bar is available here as well. Right-click menu is helpful in this part as well. You can easily open files and folders and view the files in depth. So it looks something like this. If we're going to run it in this mode here, but let's see here, images, The file menu shows extracted images from investigated PCAPs. Right click. The menu is helpful in this part as well. You can open files, zoom in and out easily. So it looks something like this here. Okay, that's pretty neat. You can see that the PCAPs collect all the information. You can analyze it straight from here. So that's pretty cool. Once you hover over the image, it shows the file's detailed information, source and destination address, and file path. So it looks something like this. So we go source destination, then the file path. Okay, parameters. The file menu shows extracted parameters from investigated PCAPs. The section provides information on parameter name, value, frame number, source and destination host, source and destination ports, timestamp, and details. Right click it. Right click menu is helpful in this part. You can copy the parameters and values easily, so that's pretty neat and handy. All right, so similar to what we just did. Keywords. File menu shows extracted keywords from investigated PCAPs. The section provides information on frame number, timestamp, keyword, context, source destination, host, and port. How the filter works: add keywords, reload case files. You can filter multiple keywords in the section. However, you must reload the case files after updating the search keywords. Keyword search investigates all possible data in the process PCAPs. Okay, so you got to remember to refresh it or reload the case files after you do this if you want to put a new keyword in there. So I guess that's pretty important information to remember. It looks something like this. So let's go ahead and continue on. Messages, chats, and messages, investigated PCAP section provides the following information here. All right, it's pretty cool. Once you filter the traffic and get a hit, you will discover additional details like attachments and attributes on the selected message. Note that the search bar is available here as well. The right-click menu is available here. You can use the built-in viewer to investigate overall information in an open file option. So that's pretty neat here. You can look at live messages and such. Anomalies. The anomalies menu shows detected anomalies in the PCAP or process PCAP. Note that NetworkMiner isn't designated as an IDS. However, developers added some detections for Eternal Blue exploit and spoofing attempts. So go ahead and Google this real quick if you're unfamiliar with Eternal Blue here. It was very, very popular in the news headlines back then. But let's go look something like this here. It's pretty cool. Now we have some questions here to answer. Once again, pause the video, try to go through these questions yourself, then come back to the video and we'll step through the process together. Okay, hopefully y'all are able to find the answers to these questions, but we're going to take a look. Now, in regards to these PCAP files, they do take about 3 to 5 minutes to load completely in NetworkMiner. So be aware of that. That's why I haven't done the next one yet. So anyway, let's take a look at this first one here, this MX-7 PCAP file. What is the name of the Linux distro mentioned in the file associated with frame 63075? So let's go over here. I already have it loaded up. There's files up here. Now what you can do is go to this particular drop down here and go to frame number. And then we're going to paste this, the number of the frame we need to get to in the filter keyword. And we're going to hit enter. And here's the one that comes up here. And when you find the Linux distro, you can see here that it mentions the CentOS distribution here, right? So that looks like that's going to be our answer, what we're looking for this particular one. And let's go back to this here. This time we need to look at the header of the page associated with frame 75,942. So once again, copy this, do the same thing here, paste it, enter. Okay, index7.html. Now for this one, you have to go in and actually open this up. So we're going to right click it and then you're going to open a file. Okay, and you'll see that the header is going to be this here, this password -ned ab. Okay, so there we go. Next one here, what is the source IP address of image ads.bmp. yada yada yada. Okay, so once again, we're going to try to filter on this keyword here. So we're going to copy and paste this over to find this information here. Okay, paste it, enter. And let's see here. I believe that we have to switch this to file name. Hit enter. There we go. Okay, and then once again, we can see some information in here, and we need to get the source address. We already see this here, source host, and this is the IP we need to grab out of here. Another way to do this, but what I did was I just right-clicked it, and I just went to file details and pulled it up here. It says source, right? And then I just copied this out of here like so. Right-click it, and then hit Control C or whatever. So anyway, so there goes that one. And the next one says, what's the frame number of the possible TLS anomaly? So for this one, you'll have to go over to, let's go ahead and clear all this out like so. Go over to anomaly section here, and you'll see there's two in here. Now the first one is the one I picked. I'm not sure if this other one works, but just grab this one out of there and plug it in as your answer. Next one, we're going to take a look at this MX-9 file. So I'm going to clear all this stuff out of here. So right click this and then remove files, reload the case, file, oops, go to open, and then this PCAP file. Now I'm going to fast forward the video because this takes a few minutes to load completely. Okay, hopefully y'all are able to answer this. If not, let's go ahead and walk through it together. Look at the messages. Which platform sent a password reset email? The next one says, what is the email address of Branson Matheson? So let's flip back over here. PCAP finally loaded up after a few minutes. So we're going to flip over to messages here. And then right away, we can already see that Facebook is mentioned here in these messages. All right, so this appears to be the platform in question here. So let's go ahead and grab this like so, copy that, flip it back over here. Facebook, done. And then we need to find the email address, and it's listed right here. So we're going to go ahead and grab this as well. All right, so let's see here. See, it says from. All right, so let's go ahead and grab that. Okay, I guess you can't do it out of there. Let's try this. All right, whatever. We're going to just type it in. So Branson at sandsite.org. And I already forgot what it was. Yeah, Branson at Sandsite. Okay. Done. Okay. Next one is task number 6, version differences. As always, it wouldn't be surprising to see a feature improvement as the version goes up. Unsurprisingly, version upgrades provide stability, security fixes, and features. Here, the feature part is quite tricky. Feature upgrades can represent implementing new features and updating the existing feature, optimization, etc., etc., etc. You can always check the changelog here. So since there are some significant differences between the versions, the given VM has both of the major versions, version 1.6 and version 2.7. Of course, as the program version increases, it is expected to increase feature increase in scope. Here are the significant differences between versions 1.6 and 2.7. Here are the differences. So MAC address processing, NetworkMiner versions after version 2 can process MAC address specific correlation as shown in the picture below. This option will help you identify if there's a MAC address conflict. This feature is not available before version 2, so we can see that here, right? So it's not in there. Okay, next one talks about can handle packets in much detail. These options help you investigate the sent and received packets in much more detailed format. The feature is not available for version 1.6, so it sounds like 2.7 is already better as expected. Okay, next one is talking about frame processing here. You can read the rest down here to see the differences. Okay. Parameter processing. All right. So I think we get the gist of this here. The, I guess, higher version, the more features it's going to have, right? So let's see here. Clear text processing says this option provides all extracted clear text data in a single tab. It is beneficial to investigate clear text data about the traffic data. However, it is impossible to match the clear text data and packets. This feature is not available after version 1.6. So there's something that's missing here, right? So this is not available after version 1.6. So I guess that's something to take note of there. All right. And all right, so question time. Once again, pause the video and try to answer the questions yourself, then come back to the video and we can continue on here. Welcome back. Now you should have been able to answer these with no problem if you just read through the task here. But anyway, let's go ahead and take a look here. Which version can detect duplicate MAC addresses? Well, that's going to be version 2.7. Which version can handle frames? That's going to be version 1.6. And which version can provide more details on packet details? And that's going to be version 1.6. So task number 7 here, we're going to get into some more practical application with exercises. It says you've learned what NetworkMiner is and how to use it. Let's put this into practice. Once again, go ahead and try to answer these questions below here, which if you've been paying attention to the video or following along, you should be able to answer these no problem, right? But if you get stuck, there's some hints over here on the side, and also we will walk through this process together. So once again, try it yourself, then come back to the video to continue on. Let's take a look here. So we need to use case 1.pcap to answer these first set of questions. What is the OS name of the host 37.122? So let's flip over here. I already have it loaded up, as you can see there. And we need to find the host name. So right away, we can see that it's a Windows box from this. But what you need is the full name in here. So you have to go down to where it says OS Windows, and then hit that drop down here. And we see the full name is going to be this Windows dash Windows NT yada yada yada. Okay, so that's our answer for that one. Next one, we got to look at these data bytes received. So the first one is from 32.91 to 37.122 on port 1065. So let's take a look at this 32.91 host. Okay, so let's go ahead and minimize all this here. All right, so we need to take a look here. There's outgoing sessions as mentioned here. And yes, so 122 to that, oh, sorry, 91 to 122. So let's flip back over here. And let's see here. That would be outgoing. So let's take a look here. And we see there's ports 1065 here, and then there's some other information over here that's mentioned, right? And we need to figure out the data bytes that were received from received from .91 to .122 on port 1065, and you'll come across our answer will be 192 data bytes sent. As you can see there, the client is 91, all right, and it's going to this .22. So our answer for that one. The next one is the opposite, so you need to take a look at this dot 122 here, and then same thing here, incoming sessions. And this time around, we need to look at the other one, port 143 here. So it says how many data bytes were received from 122 to 21 on port 143. And if we go ahead and take a look down there, we'll come across that answer as this here. We can see that the server is 122, and then it says 20,769 data bytes were sent to .21. So that's going to be our answer there, this 20,769. Okay, I think these could have been worded a lot better than this, but it is what it is. Anyway, next one says, what is the sequence number of frame 9? For this one, you have to switch to the older version of NetworkMiner. Okay, so let's go ahead and do that. I already have it pulled up here. I already have case pulled up here. When you go down to frames right there, and then frame number 9, hit that drop down, and you can see the sequence number is going to be this here. So that's going to be our answer for that one. Next one says, what is the number of detected content types? So once again, flip back over to the newer version of NetworkMiner, and you're going to go over to parameters here. Once in parameters, you can sort this by a parameter value, or sorry, parameter name here, and you see that it says content dash type. Okay, and you can see that there's only 2 listed here. Once you count them all, you have this multi-part, mixed, and then text plain. So it's going to be 2 for our answer there. There's only 2 different types. Next one, we're going to take a look at this case 2 PCAP and investigate the files. So go ahead and do that, and come back to the video once you're done, or if you need help. Let's go ahead and take a look here. Some of these were a pain in the neck to find, like these first 2 here. What is the USB product's brand name? And then we need to get the phone model as well. So the first one here, USB product. Now let's go over to Files tab. You can try to search for USB like so. Apply. There's a few in here that's mentioned. And you can see one here in particular that mentions ASIX. Now, if you do some Googling, you'll find out that's a brand name of a USB, right? And then you can get that for the answer, or you can also go to the images here, and you can sift through here for a USB image. So let's see if we can find it real quick, because it does take a little bit of time to try to sift through all these images. As you can see, there's a ton of images here, a lot of Simpsons stuff going on here. And let's see if we can locate it real quick. If not, there we go. So we can see that here, right? So you go and open it up in Chrome or whatever browser it decides to pull up here. But you can also see that it mentions the website as well. You can see that domain here. It's lagging a little bit. But if you hover over it, you can see that it mentions ASIX. So anyway, that's our answer to this question here, right? For the brand name of it. After you do some Googling, you can find out what it is, right? Looks like it finally loaded. All right, it's taking too long here. But anyway, you get the gist of it. You find this image of this USB and just Google ASIX, and you find out that this is going to be the brand of it. Or you can Google this here, which appears to be the model name of it, and you should get the answer back as ASIX. All right, the next one here is a little bit trickier. We got to find the phone model. Now, to do that, we could try it the same way. So if you go back to files here, and you could just try typing in phone, like so. It mentions like Windows Phone, okay? So I'm assuming that's a hint or something like that. Clear this out. And what you can do, you got to go over to images again and sift through all these images here, and you'll come across a couple images of phones. So let's see if I can find it real quick. All right, here we go. And the one you want to look for here is this one here. It mentions that it's a Lumia or something, right? But that's only half the information. Now, once you have that information of Lumia, you got to go back to files here. Okay, if it lets me, it's lagging a little bit. Now, once you have that piece of information in Lumia, what you want to do is go in here to files, and you're going to search on Lumia. Now you have the rest of it. Lumia 535 is going to be our answer for that one. Okay, next one is what is the source IP of fish image? Well, so once again, in files, I'm just going to type in fish, like so, hit enter, bam. Now we have the source host. This is 50.22.95.9. That's the answer for that one. Next one is what's the password of homer.pwned. Yada yada yada. So to find that, you just go to credentials here and then just look for that information. Homer, right there, right away. You can see that spring 2015. Right click, copy password, bam, done. Next one is what's the DNS query of frame 62,001. So we'll go ahead and copy this, go over to DNS, like so. Once again, search on that frame number, hit enter, and change that to frame number for some reason. Oh, okay, maybe there's a space in there. Yep, that's probably why it's not working. There we go. So we have that frame number, and this is how you get the answer. So you just gotta scroll over, and you'll see that DNS query is pop.gmx.com. So we're done with that. Awesome. So let's wrap this up with this conclusion with task number 8. Congratulations, you just finished the NetworkMiner room. In this room, we covered NetworkMiner, what is, how it operates, and how to investigate PCAP files. As I mentioned in the task before, there are a few things to remember about the NetworkMiner. Don't use this tool as a primary sniffer. Use this tool to overview the traffic, then move forward with Wireshark and TCP dump for a more in-depth investigation. There we use two different versions of NetworkMiner, right? So just be aware of the differences between the versions because you might get different information based on the versions. But as you can see, NetworkMiner can be a powerful or useful tool to add to your toolbox if you're going to be investigating network information, PCAPs, things of that nature, right? So use that as an overview, as I stated here, that get that initial triage. And if you need to dig a bit deeper, you can use a tool like Wireshark or TCP dump. Okay. So if you like this content, make sure to visit the rooms later on in THM, Wireshark, Snort, Bram, or you can check out my channel to see if I have videos over that. I know I have videos over Snort and Wireshark, so be sure to check out my channel. So we're done with this finally. And it looks like we learned quite a bit about this particular tool, but we also learned about network forensics, things of that nature. If you are curious about network forensics, be sure to use AI to help you do some research over it, or use the Google search. As always, thank you all for taking the time to watch my video. Hopefully you learned something. Hopefully you took notes. Hopefully you were able to follow along if you are a paid subscriber to TryHackMe. But thank you all for taking the time to watch the video. Be sure to like, comment, and subscribe with the notification bell. Set those notifications to all so you know every time I post to the channel. Have a nice day, and I will see you in the next one.